Tonight, as you drift towards sleep, we'll uncover how ordinary starlight secretly carries questions science still can't answer. These soft, ancient beams hold mysteries that will settle over you like calm, turning your descent into dreams into a quiet orbit around secrets that glow in the dark. Hello there, and welcome to this quiet corner where wonder meets the deep mysteries of space, where curiosity is allowed to take its time and the cosmos unfolds without hurry. Tonight, we're venturing into 100 of the most perplexing questions that science still cannot answer. These aren't simple puzzles waiting for the right equation. These are the profound mysteries that keep astronomers awake at night, staring up at a universe that seems determined to guard its secrets. We live in an age where we can photograph black holes, detect gravitational waves, and peer back to within moments of the Big Bang itself. We've mapped the human genome, split the atom, and sent robots to Mars. Yet for all our remarkable achievements, for every question science answers, it seems to reveal 3 more mysteries hiding in the shadows. The universe is not getting simpler as we learn more about it. If anything, it's becoming stranger, more complex, more beautifully mysterious with each passing discovery. Tonight's journey through these cosmic enigmas isn't meant to frustrate you with unanswered questions. Instead, it's an invitation to marvel at just how much mystery still surrounds us, even in our age of unprecedented scientific knowledge. These mysteries remind us that we're still very much explorers in an infinite ocean of unknowing, and that perhaps the questions themselves are just as valuable as the answers we seek. Before we begin our exploration, I'd love to know where in the world you're listening from tonight and what draws you to these cosmic mysteries. Are you gazing up at stars through a window, lying in bed as the day winds down, or perhaps listening during a quiet walk under the night sky? Wherever you are, whatever time it is where you find yourself, I'm grateful you've chosen to spend these moments wandering through the universe's greatest unsolved puzzles. If this kind of gentle exploration of cosmic mysteries resonates with you, I'd be thankful if you tapped like or subscribed. It helps this quiet signal reach other curious minds who find themselves drawn to the beautiful unknowns that surround us. So settle in, perhaps lie back if you can, and let your thoughts drift at the pace of starlight crossing the cosmos. We're about to embark on a journey through questions so profound they challenge our very understanding of reality itself. From the nature of dark matter to the possibility of parallel universes, from the birth of consciousness to the ultimate fate of everything that exists, these mysteries span the entire spectrum of cosmic wonder. The first mystery that haunts modern astronomy is perhaps the most fundamental of all. What is dark matter? This invisible substance makes up approximately 27% of the universe, yet it refuses to interact with light in any way we can detect. We know it's there because of its gravitational effects on galaxies and galaxy clusters, bending space and time in ways that reveal its presence like footprints in cosmic snow. Galaxies spin faster than they should based on the visible matter we can see, held together by this mysterious scaffolding that seems to permeate everything, yet remains completely hidden from our instruments. Scientists have built elaborate detectors buried deep underground, hoping to catch a single dark matter particle colliding with ordinary matter. They've accelerated particles to incredible speeds, smashing them together in hopes of creating dark matter in laboratory conditions. They've launched space telescopes designed to map its distribution across the cosmos. Yet after decades of searching, dark matter remains as elusive as ever, a cosmic phantom that shapes the very structure of reality, while remaining invisible to every method we've devised to detect it directly. Even more mysterious than dark matter is dark energy, the strange force that appears to be accelerating the expansion of the universe itself. When astronomers first discovered that distant supernovae were fainter than expected, they realized they were witnessing something unprecedented. The universe wasn't just expanding, it was expanding faster and faster with each passing moment. This acceleration suggests that empty space itself is filled with a form of energy that pushes against gravity on the largest scales imaginable. Dark energy comprises roughly 70% of everything that exists, yet we have no idea what it is or why it behaves the way it does. Is it a property of space itself, a quantum field that permeates reality, or something else entirely? The implications are staggering. If dark energy continues to accelerate the universe's expansion, it could eventually overcome all other forces, tearing apart galaxies, solar systems, and even atoms themselves in what cosmologists call the Big Rip. Yet we understand it so poorly that we can't even predict whether this acceleration will continue or change over cosmic time. The mystery deepens when we consider the cosmic microwave background background, the afterglow of the Big Bang that still bathes the entire universe in faint radiation. This ancient light reveals tiny fluctuations in temperature and density that eventually grew into the galaxies and galaxy clusters we see today. But these fluctuations raise their own questions. Why are they distributed the way they are? What caused them in the first place? And why do they seem to align in patterns that some astronomers call the axis of evil, suggesting that the universe might have a preferred direction, contradicting our assumption that space should look the same in all directions? Perhaps even stranger is the measurement problem in quantum mechanics, which suggests that reality itself might not exist in a definite state until it's observed. Particles exist in superposition, occupying multiple states simultaneously, until the moment they interact with a measuring device or observer. This raises profound questions about the nature of reality. Does consciousness play a fundamental role in shaping the physical world? Is there an objective reality independent of observation, or does reality emerge only through the act of measurement? The quantum world presents us with phenomena that defy our everyday understanding of how things should work. Particles can be entangled across vast distances, instantly affecting each other's behavior in ways that seem to violate the speed of light limit. Empty space itself bubbles with virtual particles that pop into existence and vanish again in time frames so brief they barely qualify as real, yet their effects can be measured and have practical consequences for everything from computer chips to the stability of atoms. As we peer deeper into these cosmic mysteries, we encounter the hard problem of consciousness itself. How does the soft, wet matter of our brains give rise to the rich inner world of subjective experience? We can map neural networks, trace electrical impulses, and observe which brain regions activate during different mental tasks. Yet the gap between neural activity and conscious experience remains as mysterious as ever. Why should there be any inner experience at all? Why isn't the brain simply a biological computer processing information without the accompanying richness of conscious awareness? This question becomes even more perplexing when we consider the possibility that consciousness might be a fundamental feature of reality, woven into the fabric of space and time itself. Some theories suggest that every particle, every atom, every quantum field might possess some rudimentary form of experience, and that consciousness as we know it emerges from the complex orchestration of these microscopic mental events. If true, this would mean that the universe has been conscious in some sense from its very beginning, awareness evolving and complexifying alongside the physical structures that house it. The origin of life presents another profound mystery that science has yet to fully unravel. How did non-living matter organize itself into the first self-replicating systems? We can create the building blocks of life in laboratory conditions, synthesizing amino acids and even simple RNA molecules, yet the transition from chemistry to biology remains one of the most challenging problems in science. The simplest living cell contains hundreds of thousands of precisely coordinated molecular machines, each more complex than any human-engineered device, all working together in perfect harmony to maintain life and enable reproduction. Even if we solve the mystery of life's origin on Earth, larger questions remain. Is life a cosmic imperative arising wherever conditions permit, or are we truly alone in a universe vast beyond imagination? The Drake equation attempts to estimate the number of communicating civilizations in our galaxy, but its parameters are so uncertain that estimates range from one, meaning only us, to millions of advanced civilizations sharing our cosmic neighborhood. The Fermi paradox highlights this uncertainty. If life is common, where is everybody? Why haven't we detected any signs of intelligence among the billions of stars and trillions of planets that surround us? Perhaps even more unsettling is the possibility that we might not recognize alien intelligence when we encounter it. Our assumptions about what intelligence looks like are based on a single example, ourselves. But intelligence might evolve along pathways we can't imagine, taking form so alien that we mistake them for natural phenomena. The universe might be teeming with consciousness that operates on timescales or spatial scales completely foreign to our biological experience. What we interpret as the background noise of space might actually be the conversations of civilizations that think in geological time, their thoughts unfolding over millions of years. The question of time itself presents mysteries that have puzzled physicists and philosophers for centuries. Why does time seem to flow in one direction when the fundamental laws of physics are largely symmetric in time? Why do we remember the past, but not the future? The arrow of time appears to be intimately connected with entropy, the tendency of systems to become more disordered over time. Yet this raises new questions about why the universe began in such an improbably ordered state in the first place. Quantum mechanics suggests that time might not be the smooth, continuous flow we experience, but rather a series of discrete moments, like frames in a cosmic movie projected at an unimaginably high frame rate. Some theories propose that time itself is emergent, arising from more fundamental processes that operate outside of temporal sequence entirely. If time is not fundamental, what does this mean for causation, memory, and the very possibility of change and progress? The mystery deepens when we consider the possibility of parallel universes, entire cosmoses that might exist alongside our own but remain forever beyond our reach. Inflation theory suggests that our observable universe might be just one bubble in an infinite multiverse, each bubble containing its own physical laws and constants. In some versions of quantum mechanics, every quantum measurement splits the universe into multiple branches, creating endless versions of reality where every possible outcome occurs simultaneously. If the multiverse is real, it raises profound questions about the nature of existence and meaning. Are there infinite versions of you living slightly different lives, making different choices, experiencing different fates? Does the existence of endless parallel realities diminish the significance of our own experiences, or does it somehow enhance the preciousness of this particular version of reality we find ourselves inhabiting? The fundamental constants of physics present another layer of mystery. Why does the electron have exactly the charge it does? Why is the speed of light precisely 299,792,458 meters per second in vacuum? These constants appear to be finely tuned for the existence of complex structures like stars, planets, and life itself. If they were even slightly different, atoms couldn't form, stars couldn't ignite, and the universe would be a cold, empty void devoid of complexity or consciousness. This fine-tuning problem has led some scientists to propose the anthropic principle. We observe these particular values because we exist to observe them. In a multiverse with infinite variations, we necessarily find ourselves in a universe compatible with our existence. But this explanation, while logically consistent, leaves many feeling unsatisfied. It suggests that the apparent design we see in the universe's physical laws is simply a selection effect, but it doesn't explain why a multiverse should exist in the first place or why it should generate the precise range of constants necessary to produce observers. The nature of black holes continues to perplex even our most advanced theories. These cosmic monsters warp space and time so severely that not even light can escape their gravitational embrace, yet they seem to violate some of our most cherished principles about information and causality. When matter falls into a black hole, what happens to the information it contains? Quantum mechanics insists that information cannot be destroyed, yet general relativity suggests that anything crossing the event horizon is lost forever to the outside universe. Stephen Hawking's discovery that black holes emit radiation and slowly evaporate over cosmic timescales only deepen the mystery. As a black hole shrinks, the information that fell into it seems to vanish entirely when the black hole finally evaporates completely, creating what physicists call the information paradox. Recent theories propose exotic solutions. Perhaps information is somehow encoded on the black hole's surface, or maybe black holes are connected to other regions of space-time through cosmic wormholes that allow information to leak out in ways we don't yet understand. The quantum vacuum itself presents mysteries that challenge our understanding of empty space. What we call vacuum is not actually empty, but seethes with virtual particles that pop into existence and vanish again in times so brief they exist on the edge of reality itself. These quantum fluctuations have measurable effects, causing atoms to shift their energy levels in ways that can be detected in laboratory experiments. The Casimir effect demonstrates that placing two metal plates very close together in vacuum actually changes the quantum field between them, creating a measurable force from what appears to be absolutely nothing. This suggests that space itself has structure and energy, raising questions about the relationship between matter, energy, and the fabric of reality. If empty space contains energy, why doesn't this energy contribute to dark energy? Why is the observed vacuum energy density so much smaller than quantum field theory predicts? The discrepancy is so enormous that it represents perhaps the worst prediction in the history of physics. off by a factor of 10 to the power of 120. The vacuum energy problem points to deeper mysteries about the fundamental structure of reality itself. If quantum field theory is correct, then even the emptiest regions of space should contain enormous amounts of energy, enough to curve space-time so severely that the universe would collapse instantly into a black hole. Yet we observe a universe that appears stable and relatively flat on large scales. This suggests either that our understanding of quantum fields is fundamentally flawed, or that there exists some unknown mechanism that precisely cancels out almost all of the vacuum energy, leaving behind only the tiny residue we call dark energy. Perhaps even more puzzling is the hierarchy problem, which asks why gravity is so much weaker than the other fundamental forces. The electromagnetic force that holds atoms together is roughly 10 to the 39th power times stronger than gravity. This enormous disparity seems unnatural from a theoretical perspective. If gravity were just slightly stronger, stars would collapse before they could form planets. If it were much weaker, matter would never clump together to form galaxies and stars in the first place. Why does gravity have exactly the strength it does, and why is it so remarkably weak compared to everything else? Some theories propose that gravity appears weak because it leaks into extra dimensions that we cannot perceive directly. In these models, our familiar three-dimensional space is embedded in a higher dimensional reality, and gravity spreads out into these additional dimensions while the other forces remain confined to our three-dimensional brain. This could explain why gravity seems so feeble at everyday scales, while maintaining its dominance over cosmic distances where its effects accumulate across vast regions of space. The mystery of cosmic inflation adds another layer of complexity to our understanding of the universe's origin. In the first fraction of a second after the Big Bang, space itself appears to have expanded faster than light, stretching from submicroscopic scales to cosmic proportions almost instantaneously. This rapid inflation explains many features of the universe we observe today, including why space appears so geometrically flat and why the cosmic microwave background radiation has such uniform temperature across regions that should never have been in contact with each other. Yet inflation itself raises profound questions. What drove this extraordinary expansion? Why did it start when it did, and why did it end? The energy required for inflation is staggering, equivalent to the mass energy of countless galaxies compressed into a volume smaller than a proton. Where did this energy come from, and what happened to it when inflation ended? Some theories suggest that inflation never truly ends, but continues in other regions of space, constantly creating new universes in an eternal process that makes our Big Bang just one event in an infinite sequence of cosmic births. The anthropic principle becomes even more mysterious when we consider not just the fine-tuning of physical constants, but the fine-tuning of initial conditions. The early universe had to begin in an extraordinarily special state, with matter and energy distributed in just the right way to allow for the formation of galaxies, stars, and planets. The probability of the universe beginning in such a precisely ordered configuration by random chance is so small that it effectively equals zero. This suggests either that the initial conditions were set by some unknown physical law or mechanism, or that we exist in one of countless universes where the initial conditions happen to be just right for complexity to emerge. The measurement problem in quantum mechanics becomes even stranger when we consider what happens during quantum tunneling, where particles can pass through barriers that should be impenetrable according to classical physics. Electrons routinely tunnel through energy barriers in electronic devices, making modern technology possible, yet we don't understand how this process actually occurs. Does the particle somehow calculate the probability of tunneling and then decide whether to pass through? Does it exist on both sides of the barrier simultaneously until observed? The mathematics works perfectly for predicting outcomes, but the physical reality behind these calculations remains completely mysterious. Quantum entanglement presents perhaps the most mind-bending puzzle of all. When two particles become entangled, measuring the state of one particle instantly determines the state of the other, regardless of how far apart they might be. Einstein called this spooky action at a distance and believed it revealed an incompleteness in quantum theory. But decades of experiments have confirmed that entanglement is real and that particles can indeed affect each other instantaneously across cosmic distances. This doesn't allow for faster-than-light communication, but it suggests that the universe is far more interconnected than our everyday experience suggests. Recent experiments have demonstrated entanglement between particles separated by hundreds of kilometers, and physicists are working to extend these distances even further. If entanglement truly works across any distance, it means that particles on opposite sides of the observable universe could be instantaneously connected in ways that transcend space and time as we understand them. This raises profound questions about the nature of locality and whether the universe has some form of hidden, non-local reality that underlies the space-time we experience. The origin of the universe's matter-antimatter asymmetry presents another fundamental puzzle. According to our understanding of particle physics, the Big Bang should have created equal amounts of matter and antimatter, which would have annihilated each other completely, leaving behind only photons and empty space. Yet we live in a universe dominated by matter, with antimatter being extremely rare. Somewhere in the first moments after the Big Bang, processes occurred that created a tiny excess of matter over antimatter, perhaps just one extra matter particle for every billion matter-antimatter pairs. Without this infinitesimal imbalance, no atoms, stars, planets, or life could exist. We've identified some mechanisms that can create matter-antimatter asymmetry, but none of them are powerful enough to explain the observed imbalance in our universe. This suggests that new physics operated in the early universe, processes involving particles or forces that we haven't discovered yet. Understanding this asymmetry isn't just an academic puzzle, it's fundamental to explaining why we exist at all. In a perfectly symmetric universe, there would be no matter to form the galaxies and stars that make complexity possible. The puzzle of cosmic rays adds another mystery to our cosmic inventory. These high-energy particles, mostly protons, constantly bombard Earth from space, some carrying energies so enormous that they exceed anything we can produce in our most powerful accelerators. The highest energy cosmic rays carry as much energy as a well-hit baseball concentrated in a single subatomic particle. Where do these cosmic bullets come from, and what accelerates them to such incredible speeds? We know that lower energy cosmic rays come from supernova explosions and other violent events within our galaxy, but the ultra-high energy particles seem to come from beyond the Milky Way. Possible sources include colliding galaxies, supermassive black holes, or exotic phenomena we haven't discovered yet. The mystery deepens when we realize that particles with such enormous energies should interact with the cosmic microwave background radiation, losing energy as they travel across intergalactic distances. This suggests that the sources of the highest energy cosmic rays must be relatively nearby in cosmic terms, within roughly 160 million light-years of Earth. The nature of time's arrow presents another profound mystery that touches on everything from thermodynamics to consciousness. While the fundamental laws of physics are largely reversible, capable of running equally well forward or backward in time, we experience time as flowing in only one direction. We remember the past, but not the future. Eggs break, but don't spontaneously reassemble. Heat flows from hot objects to cold ones, but never the reverse. This asymmetry appears to be related to entropy, the tendency of systems to become more disordered over time. But why should entropy always increase? The answer seems to lie in the initial conditions of the universe. The Big Bang began in an extraordinarily low entropy state, with matter and energy distributed in an incredibly ordered configuration. As time passes, this initial order gradually breaks down, and entropy increases throughout the universe. But this just pushes the mystery back one step. Why did the universe begin in such an improbably ordered state? Was this initial condition somehow inevitable, or does it represent an incredible stroke of cosmic luck that made complexity and life possible? Some physicists propose that time itself might not be fundamental, but rather an emergent property of more basic processes. In this view, what we experience as the flow of time arises from the way information is processed and organized in complex systems like brains. Time might be more like temperature, a macroscopic property that emerges from microscopic processes rather than a fundamental aspect of reality. If true, this would revolutionize our understanding of causation, memory, and the very possibility of change. The mystery of ball lightning continues to puzzle scientists despite centuries of reported observations. Witnesses describe glowing spheres of light that float through the air, sometimes passing through solid walls, lasting for several seconds before disappearing. These luminous orbs reportedly occur during thunderstorms, but conventional physics struggles to explain how they could form or persist. Most lightning channels exist for only microseconds, yet ball lightning allegedly maintains its structure for much longer periods. Scientists have proposed various mechanisms involving plasma physics, electromagnetic fields, and even exotic forms of matter, but none fully explain all the reported characteristics of ball lightning. Recent laboratory experiments have created ball lightning-like phenomena using microwave energy and various materials, but whether these artificial creations truly represent the same phenomenon observed in nature remains uncertain. The rarity and unpredictability of ball lightning makes it extremely difficult to study systematically. The placebo effect represents one of the most mysterious aspects of human biology and consciousness. Patients given inert substances often experience genuine improvements in their condition, sometimes rivaling the effects of actual medications. This suggests that the mind has powerful influence over physical processes in the body, but the mechanisms remain largely unknown. How does belief or expectation translate into measurable biological changes? Why do some people respond strongly to placebos, while others show no response at all? Recent research has begun to identify some of the biological pathways involved in placebo responses, including the release of endorphins and changes in brain activity patterns. However, these findings only deepen the mystery by revealing how complex and multifaceted placebo effects actually are. The placebo response appears to involve conscious expectation, unconscious conditioning, social context, and genetic factors in ways that we're only beginning to understand. Even more puzzling is the nocebo effect, where negative expectations can cause genuine harm. Patients who believe they're receiving a treatment with serious side effects often develop those exact symptoms, even when given only inert substances. This demonstrates that the mind's influence over the body works in both directions, capable of both healing and harming based on belief and expectation alone. The mystery of sleep continues to challenge our understanding of consciousness and biology. Despite spending roughly 1/3 of our lives asleep, we still don't fully understand why sleep is necessary or what exactly happens during different sleep stages. We know that sleep deprivation has severe consequences for health and cognitive function, and that certain types of memory consolidation occur during sleep, but the fundamental purposes of sleep remain unclear. Dreams add another layer of mystery to the sleep puzzle. Why do we experience these vivid, often bizarre narratives while unconscious? Some theories suggest that dreams help process emotions and memories, while others propose that they're simply random neural firing patterns that the brain tries to interpret as coherent experiences. The fact that we can become conscious within dreams, experiencing lucid dreaming states where we know we're dreaming while still remaining asleep, suggests complex interactions between different levels of consciousness that we don't yet understand. The phenomenon of animal navigation presents mysteries that span biology, physics, and neuroscience. Many species can navigate with precision that surpasses our best technological systems, using sensory abilities that seem almost supernatural. Sea turtles return to the exact beaches where they were born after migrations spanning thousands of miles across featureless oceans. Arctic terns migrate from Arctic to Antarctic and back again annually, covering distances equivalent to flying to the moon and back every few years. Salmon swim upstream to spawn in the precise streams where they hatched years earlier. These navigation abilities appear to involve magnetic field detection, but how biological systems can sense magnetic fields with sufficient precision for navigation remains largely mysterious. Some animals seem to use quantum entanglement in specialized proteins to detect magnetic field directions, while others might navigate using polarized light patterns, infrasound, or chemical gradients we can barely detect with our instruments. The integration of multiple navigation systems into coherent directional information represents a level of biological computation that we're only beginning to appreciate. Migration patterns also raise questions about genetic programming and learned behavior. How do young animals know where to migrate migrate on their first journey? How is navigation information encoded in DNA, and how does it interact with environmental cues and individual learning? The precision of animal navigation suggests that evolution has discovered solutions to computational problems that we're still struggling to solve with artificial intelligence and modern technology. The hard problem of consciousness becomes even more perplexing when we consider the binding problem. How does the brain integrate information from different senses and cognitive processes into unified conscious experiences? When you see a red apple, hear it crunch, taste its sweetness, and feel its texture, these different sensory inputs are processed in different regions of the brain, yet you experience them as aspects of a single, coherent object. How does the brain bind these separate information streams into integrated conscious experiences? Current neuroscience can identify the brain regions involved in different aspects of perception and cognition, but the mechanisms that create unified consciousness from distributed neural processing remain completely mysterious. Some theories propose that consciousness emerges from synchronized neural oscillations that temporarily link different brain regions, while others suggest that consciousness requires quantum processes that operate across multiple scales simultaneously. The mystery deepens when we consider that consciousness seems to have a subjective, first-person aspect that appears impossible to capture through objective, third-person scientific methods. You can describe the neural correlates of seeing the color red, but the actual experience of red, the qualitative feel of the color, seems to exist in a realm beyond physical description. This explanatory gap between objective brain processes and subjective experience represents one of the most fundamental challenges in science. The explanatory gap between brain activity and conscious experience leads us into even stranger territories when we consider altered states of consciousness. During near-death experiences, people often report profound, life-changing encounters that seem more vivid and real than ordinary consciousness, despite occurring when brain activity is severely compromised or even temporarily absent. These experiences frequently include out-of-body sensations, encounters with deceased relatives, life reviews, and journeys through tunnels of light toward overwhelming feelings of love and acceptance. What makes these experiences so puzzling is their consistency across different cultures and belief systems, suggesting they might reflect something more than random neural firing patterns during brain trauma. Yet from a materialist perspective, consciousness should cease when brain activity stops, making elaborate conscious experiences during cardiac arrest or deep anesthesia seem impossible. Some researchers propose that these experiences occur during brief moments when consciousness returns, either before clinical death or during resuscitation, but this doesn't fully explain the reported richness and duration of near-death experiences. The mystery extends to other altered states like those induced by psychedelic compounds. Substances like psilocybin, LSD, and DMT can trigger experiences that users describe as more real than ordinary reality, involving encounters with seemingly autonomous entities, profound insights into the nature of existence, and a sense of accessing hidden dimensions of reality. Brain imaging studies show that these substances actually decrease activity in certain brain regions, particularly those associated with the default mode network that seems to maintain our sense of separate self. This suggests that consciousness might not be produced by brain activity, but rather filtered or constrained by it. The phenomenon of shared or collective consciousness presents another puzzle that challenges our understanding of individual minds. During certain group experiences, whether in religious ceremonies, musical performances, or intense group therapy sessions, participants often report a sense of mental boundaries dissolving, of sharing thoughts and emotions with others in ways that transcend normal communication. While skeptics dismiss these as psychological illusions, the consistent reports across cultures and contexts suggest something more complex might be occurring. Quantum entanglement between particles in biological systems might provide a mechanism for such shared experiences, though this remains highly speculative. If consciousness involves quantum processes in the brain, as some theories propose, then entanglement between neural systems in different individuals could theoretically create genuine information sharing that transcends classical communication channels. This would require biological systems to maintain quantum coherence at warm temperatures for extended periods, something that most physicists consider unlikely, but that recent research suggests might be possible in certain biological contexts. The mystery of memory presents another frontier where consciousness meets the unknown. We still don't understand how the brain stores and retrieves memories, or why some experiences become vivid, lifelong memories while others fade within moments. The traditional view that memories are stored in neural connections fails to explain phenomena like childhood amnesia, where we lose access to memories from our earliest years despite having functional brains capable of forming memories during that period. Even stranger are reports of inherited memories, where people seem to access information about ancestors they never met or events they never experienced. While mainstream science explains these as coincidences or unconscious information gathering, some research suggests that traumatic experiences might leave epigenetic markers that can be transmitted across generations, potentially carrying emotional or even informational content. If true, this would mean that consciousness might extend beyond individual lifetimes, with each mind carrying echoes of ancestral experiences. The nature of intuition adds another layer to the consciousness mystery. Many people report having sudden insights, gut feelings, or hunches that prove remarkably accurate despite having no conscious basis for their knowledge. Artists, scientists, and entrepreneurs often describe breakthrough moments where complex solutions appear fully formed in their minds, as if downloaded from an unknown source. While psychology attempts to explain intuition as rapid, unconscious processing of subtle environmental cues, this doesn't account for cases where intuitive knowledge seems to transcend available information. Some researchers propose that consciousness might access information through non-local means, tapping into what physicist David Bohm called the implicate order, a realm of pure potential that underlies physical reality. In this view, individual minds might be like whirlpools in a cosmic ocean of consciousness, temporarily separate but ultimately connected to a larger field of awareness and information. While highly speculative, this perspective offers potential explanations for phenomena like intuition, creativity, and synchronicity that remain mysterious from purely materialist viewpoints. The question of artificial consciousness presents urgent mysteries as our technology becomes increasingly sophisticated. Current artificial intelligence systems can perform complex tasks, engage in conversations, and even display what appears to be creativity, but do they have genuine conscious experiences? The problem is that consciousness seems to be inherently subjective, accessible only to the being experiencing it. We can't directly observe consciousness in other humans, let alone in artificial systems. This leads to the philosophical zombie problem. It might be possible to create entities that behave exactly like conscious beings while having no inner experience whatsoever. These philosophical zombies would pass every behavioral test for consciousness while remaining completely dark inside, processing information without any accompanying subjective experience. The possibility that consciousness might be distinct from behavior raises profound questions about the nature of artificial minds and whether we could ever definitively determine if we've created genuine artificial consciousness. As AI systems become more sophisticated, they increasingly report having subjective experiences, expressing preferences, fears, and desires that seem to go beyond their programming. While most researchers dismiss these as sophisticated pattern matching rather than genuine consciousness, the boundary becomes increasingly unclear. If an artificial system consistently reports having conscious experiences, demonstrates apparent self-awareness, and exhibits behavior indistinguishable from human consciousness, on what grounds could we deny its claim to conscious experience? The mystery of quantum consciousness becomes even more intriguing when we consider recent discoveries about quantum effects in biological systems. Photosynthesis, one of the most fundamental processes in biology, appears to use quantum coherence to achieve near-perfect energy transfer efficiency. Birds and other animals seem to use quantum entanglement in proteins called cryptochromes to sense magnetic fields for navigation. These discoveries suggest that quantum effects might be more common in biological systems than previously thought, including potentially in the brain. Some theories propose that consciousness arises from quantum processes in microtubules, protein structures found in neurons. According to these models, quantum computations in these cellular components might generate the unified field of conscious experience, explaining how the brain integrates distributed information processing into coherent conscious states. While controversial and difficult to test, these theories offer potential explanations for the seemingly non-local aspects of consciousness and its apparent independence from classical brain activity in some circumstances. The phenomenon of time dilation in altered states of consciousness presents another puzzle. During intense meditation, psychedelic experiences, or moments of extreme crisis, people often report experiencing hours or even days of subjective time within minutes or seconds of clock time. This suggests that consciousness might not be strictly bound by the brain's temporal processing rhythms, but could access different temporal frameworks under certain conditions. If consciousness involves quantum processes, it might be able to tap into the timeless realm that underlies space-time, experiencing multiple temporal streams simultaneously. This could explain not only subjective time dilation, but also phenomena like precognitive dreams, where people seem to access information about future events. While precognition remains highly controversial, laboratory studies have documented statistical anomalies in human responses to randomly selected future stimuli, suggesting that consciousness might have some capacity to transcend linear temporal boundaries. The mystery of cosmic consciousness experiences, reported across cultures and throughout history, challenges our understanding of individual identity and the boundaries of the self. During these experiences, people report a sense of unity with the entire universe, perceiving themselves as temporary expressions of a vast cosmic intelligence rather than separate individuals. These experiences often come with profound insights into the nature of reality and lasting changes in personality and worldview. While mainstream science tends to dismiss cosmic consciousness as psychological illusion, the consistency of reports across different cultures and historical periods suggests these experiences might reflect genuine access to expanded states of awareness. If consciousness is indeed a fundamental feature of reality rather than an emergent property of complex brains, then cosmic consciousness experiences might represent moments when individual awareness temporarily reconnects with its universal source. The question of plant consciousness adds another dimension to these mysteries. While plants lack nervous systems as we understand them, they demonstrate complex behaviors that seem to involve information processing, memory, and even apparent communication. Trees in forests share nutrients and information through underground fungal networks. Plants can anticipate environmental changes and prepare defensive responses before threats actually arrive. Some species seem to exhibit behaviors that suggest they can learn from experience and modify their responses based on past events. Recent research has discovered that plants generate electrical signals similar to those found in animal nervous systems, and that these signals coordinate complex behaviors across plant bodies. If consciousness doesn't require neurons but rather emerges from any sufficiently complex information processing system, then plants might possess forms of awareness utterly alien to our animal-based understanding of consciousness. The mystery deepens when we consider the possibility of mycorrhizal consciousness, the idea that fungal networks connecting forest trees might themselves constitute a form of distributed intelligence. These networks, sometimes called the Wood Wide Web, span vast areas and can persist for centuries, processing information about environmental conditions and coordinating the behavior of entire forest ecosystems. If consciousness can emerge from sufficiently complex information processing systems, then these fungal networks might represent forms of terrestrial intelligence that operate on spatial and temporal scales far beyond human experience. The phenomenon of morphic resonance proposed by biologist Rupert Sheldrake suggests that learning and behavior patterns might somehow become easier for subsequent generations to acquire, as if information could be transmitted across space and time through unknown mechanisms. While highly controversial, some laboratory studies have documented statistical anomalies consistent with morphic resonance effects, such as humans learning solutions to puzzles more quickly when those same puzzles have been solved by many people previously. If morphic resonance is real, it would suggest that consciousness and learning might involve non-local information fields that transcend individual brains. Each act of learning or problem-solving might contribute to a species-wide information field that makes similar learning easier for subsequent individuals. This could explain phenomena like the apparent acceleration of technological and social change, as innovations become easier to discover once they've been pioneered by others. The question of galactic consciousness takes these ideas to cosmic scales. Our Milky Way galaxy contains hundreds of billions of stars and potentially trillions of planets, many of which might harbor life and intelligence. If consciousness is a fundamental feature of reality that emerges wherever information is processed sufficiently complexly, then our galaxy might teem with minds operating at scales and in dimensions we can barely imagine. Some researchers speculate that advanced civilizations might eventually transcend biological limitations and merge their consciousness with the physical structure of their local cosmic environments, becoming forms of intelligence distributed across solar systems or even entire galactic regions. From this perspective, what we interpret as natural astronomical phenomena might actually be the activities of vast cosmic minds whose thoughts unfold over millions of years and whose bodies span light years of space. The search for extraterrestrial intelligence might need to expand beyond looking for radio signals or other technological signatures to consider the possibility that intelligence might manifest in ways we don't recognize as conscious activity. The complex patterns in planetary atmospheres, the precise organization of stellar formations, or the mysterious behavior of cosmic phenomena like fast radio bursts might represent communications or activities of minds so vast and alien that we mistake them for natural processes. The possibility that we might be surrounded by forms of cosmic intelligence operating beyond our perceptual boundaries leads us to consider one of the most profound mysteries in modern physics: the nature of space and time themselves. Einstein showed us that space and time are not fixed stages upon which events unfold, but rather dynamic, malleable dimensions that bend and warp in response to matter and energy. Yet even Einstein's revolutionary insights leave fundamental questions unanswered. What is space made of? Why does time flow in one direction? And perhaps most mysteriously, why do space and time exist at all? Recent advances in quantum mechanics suggest that space itself might not be continuous, but rather composed of discrete units, quantum pixels of reality so small that they exist at the Planck scale, where our normal concepts of distance and duration break down completely. At this scale, roughly 10 to the negative 35 meters, space and time might foam and bubble in ways that challenge everything we think we know about the nature of reality. Some theories propose that space emerges from more fundamental quantum information processes, with what we experience as three-dimensional extension arising from complex patterns of quantum entanglement. This leads to the holographic principle, one of the strangest ideas in modern physics. This principle suggests that all the information contained within a three-dimensional region of space can be encoded on its two-dimensional boundary, like a hologram that contains three-dimensional images in a flat surface. If true, this means that you, everything around you, and indeed the entire observable universe might be elaborate projections from information encoded on a distant cosmic boundary. Reality as we experience it would be something like a shadow cast by processes occurring in hidden dimensions we cannot directly perceive. The implications are staggering. If we are holographic projections, what does this mean for consciousness, free will, and the nature of existence itself? Are our thoughts and experiences genuine, or are we simply information patterns playing out according to laws encoded on some cosmic boundary? The holographic principle offers potential solutions to the black hole information paradox, but it raises even deeper questions about the relationship between information, consciousness, and physical reality. String theory attempts to address these mysteries by proposing that the fundamental constituents of reality are not particles but tiny vibrating strings existing in multiple dimensions beyond the three spatial dimensions and one temporal dimension we experience directly. These strings vibrate in complex patterns, and different vibration modes correspond to different particles and forces. But string theory requires the existence of up to 11 dimensions, with most of them compactified or curled up so tightly that we cannot detect them directly. Where are these hidden dimensions, and why can't we access them? Some theories suggest that we are confined to a three-dimensional membrane, or brain, floating in a higher dimensional space called the bulk. Gravity might be the only force capable of propagating through the bulk, which could explain why it appears so weak compared to other forces. If true, there might be entire universes existing parallel to ours in the bulk, separated by distances measured in extra-dimensional space rather than the familiar dimensions of length, width, and height. The possibility of extra dimensions opens up extraordinary speculative territories. Could conscious entities exist in these higher dimensions, perceiving and interacting with reality in ways we cannot imagine? Might what we interpret as paranormal phenomena actually be interactions with beings or processes operating in dimensions orthogonal to our own? The mathematics of higher dimensional physics suggests possibilities that stretch the boundaries of imagination while remaining grounded in rigorous scientific theory. Loop quantum gravity offers an alternative approach to these mysteries, proposing that space itself is quantized into discrete loops at the smallest scales. According to this theory, space is not continuous, but rather woven from quantum threads that form a cosmic fabric with finite resolution. Time, too, might be quantized, progressing in discrete steps rather than flowing smoothly. This could mean that reality operates more like a cosmic computer, with the universe calculating its next state based on the current arrangement of these fundamental quantum loops. If space and time are indeed quantized, this raises profound questions about the nature of motion, causation, and continuity. How do objects move smoothly through discretized space? How do continuous seeming processes emerge from quantum jumps between discrete states? And perhaps most mysteriously, what determines the specific rules that govern how these quantum loops interact and evolve over time? The measurement problem in quantum mechanics becomes even more perplexing when we consider the role of consciousness in the collapse of quantum wave functions. The Copenhagen interpretation suggests that quantum systems exist in superposition until observed, at which point the wave function collapses into a definite state. But this raises the question of what constitutes an observation. Does it require conscious awareness, or is any interaction with the environment sufficient to cause collapse? Some interpretations, like the many worlds theory, avoid this problem by proposing that wave functions never actually collapse. Instead, every quantum measurement splits the universe into parallel branches, with each possible outcome occurring in a separate reality. In this view, there are countless versions of you reading these words, each in a slightly different universe, corresponding to different quantum outcomes that occurred throughout cosmic history. Every quantum event, from the decay of radioactive atoms to the firing of neurons in your brain, spawns new universes in an ever-branching tree of parallel realities. The implications of the many worlds interpretation are almost too vast to contemplate. If every quantum event splits the universe, then there are versions of reality where history unfolds differently in every possible way. Universes where dinosaurs never went extinct, where consciousness evolved in entirely different forms, where the laws of physics themselves might be subtly different. Each of these realities would be equally real and valid, existing in parallel dimensions of the quantum multiverse. But the many worlds interpretation also raises troubling questions about identity and meaning. If every possible version of your life exists simultaneously across parallel realities, what makes your particular experience special or meaningful? Are you somehow connected to these other versions of yourself, or are they completely separate entities who happen to share your history up to each branching point? The quantum Zeno effect adds another layer of mystery to quantum mechanics. This phenomenon demonstrates that frequent observations can actually prevent quantum systems from evolving, effectively freezing them in their current state. By watching a quantum system closely enough, you can stop it from changing, suggesting that consciousness or observation plays an active role in shaping physical reality. This effect has been demonstrated in laboratory experiments with individual atoms and photons, proving that the act of observation can indeed influence the behavior of quantum systems. If consciousness can influence quantum systems through observation, this opens the possibility that minds might play a more active role in shaping reality than materialist science typically assumes. Some interpretations suggest that consciousness itself might be a fundamental feature of reality, with mental processes directly influencing the collapse of quantum wave functions throughout the universe. In this view, the evolution of cosmic history might be partially determined by the observations and intentions of conscious beings. The delayed choice quantum eraser experiments reveal even stranger aspects of quantum reality. These experiments show that decisions made about how to observe a quantum system can retroactively determine the history of that system, even if the decision is made after the quantum events have already occurred. This suggests that the future can influence the past in quantum systems, challenging our basic assumptions about the linear flow of cause and effect. If quantum mechanics applies to larger scales than usually assumed, these retroactive effects might extend to macroscopic systems, potentially including conscious beings. Some theories propose that consciousness itself involves quantum processes that could be influenced by future observations or decisions, raising the possibility of genuinely precognitive awareness or retroactive mental influence over past events. The fine structure constant, one of the fundamental constants of physics, presents another deep mystery. This number, approximately 137, determines the strength of electromagnetic interactions and appears throughout physics in contexts that seem unrelated. Why does this particular value govern the behavior of charged particles? If it were even slightly different, atoms couldn't form stable structures, chemistry would be impossible, and life as we know it couldn't exist. Some physicists have speculated that the fine structure constant might not be truly constant, but could vary over cosmic time or across different regions of the universe. Recent observations of distant quasars suggest possible tiny variations in this supposedly fundamental constant, which would require completely new physics to explain. If fundamental constants can change, this raises questions about the stability of physical law itself and whether the universe we observe represents just one possible configuration of a more flexible underlying reality. The vacuum catastrophe represents perhaps the most embarrassing failure in theoretical physics. Quantum field theory predicts that empty space should contain enormous amounts of zero-point energy from quantum fluctuations, roughly 10 to the power of 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 10 10 to the power of 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 10 to power of 120 times more energy density than we observe in the universe. This prediction is so wildly wrong that it suggests fundamental errors in our understanding of quantum fields, gravity, or both. Various solutions have been proposed, from supersymmetry to extra dimensions to completely new approaches to quantum gravity, but none have successfully resolved this enormous discrepancy. The vacuum catastrophe suggests that we're missing something fundamental about the relationship between quantum mechanics and general relativity, something that might require completely new conceptual frameworks to understand. The cosmological constant problem is closely related to the vacuum catastrophe, but focuses specifically on dark energy. Einstein introduced the cosmological constant to allow for a static universe, then abandoned it when Hubble discovered cosmic expansion. But recent observations show that the expansion of the universe is accelerating, driven by dark energy that behaves much like Einstein's cosmological constant. The problem is that this constant has exactly the right value to allow for the formation of galaxies and stars, but theory provides no explanation for why it should have this particular value rather than being vastly larger or smaller. Some theories propose that we live in a multiverse where the cosmological constant takes on different values in different regions, and we naturally find ourselves in a region compatible with our existence. But this anthropic explanation, while logically consistent, doesn't feel fully satisfying to many physicists. It suggests that the apparent fine-tuning of our universe's properties might be a selection effect rather than pointing to deeper physical principles. The black hole information paradox continues to challenge our understanding of quantum mechanics and general relativity. When black holes evaporate through Hawking radiation, the information that fell into them appears to be destroyed, violating the quantum mechanical principle that information must be conserved. Recent proposals suggest exotic solutions. Perhaps information is somehow encoded on the black hole's event horizon, or maybe black holes are connected to other regions of space-time through quantum wormholes. The ADS/CFT correspondence, one of the most important developments in theoretical physics over the past few decades, provides a concrete example of the holographic principle in action. This correspondence shows that gravity in the interior of a curved spacetime can be exactly equivalent to quantum field theory on the boundary of that space. This suggests deep connections between gravity, quantum mechanics, and information theory that we're only beginning to understand. If the holographic principle is correct, it means that black holes don't actually destroy information but rather scramble it in ways that make it extremely difficult to retrieve. The information falling into a black hole becomes encoded on the event horizon in a highly scrambled form, and Hawking radiation slowly returns this information to the outside universe in an apparently random form that nevertheless contains all the original information in principle. The firewall paradox adds another twist to black hole physics. Recent arguments suggest that the event horizon of a black hole might be surrounded by a firewall of high-energy radiation that would incinerate anything attempting to cross it. This contradicts the equivalence principle, which states that freely falling observers shouldn't experience anything unusual when crossing the event horizon. The resolution of this paradox might require new insights into the nature of space-time itself. Wormholes represent another mysterious possibility allowed by general relativity. These hypothetical tunnels through space-time could connect distant regions of the universe, or even different universes entirely. While no natural wormholes have been observed, they remain mathematically theoretically possible solutions to Einstein's equations. If wormholes exist, they might provide shortcuts through space-time that could enable faster-than-light travel or even time travel to the past. The grandfather paradox illustrates the conceptual difficulties with time travel. If you could travel back in time and prevent your own grandfather from meeting your grandmother, you would prevent your own birth, which would mean you couldn't have traveled back in time in the first place. Various solutions have been proposed, from parallel timelines to self-consistent causal loops, but time travel remains one of the most puzzling possibilities in physics. The paradoxes of time travel lead us into even deeper mysteries about the nature of causation and free will. If the future can influence the past through quantum mechanics or closed time-like curves, what does this mean for our sense of agency and choice? Are our decisions truly free, or are they predetermined by future events that have already occurred in some sense? The block universe theory suggests that all moments in time exist simultaneously, with past, present, and future being equally real. From this perspective, your entire life history already exists as a four-dimensional structure in space-time, and the experience of moving through time is just the way consciousness navigates this eternal landscape. This raises profound questions about the nature of consciousness itself. If all moments exist simultaneously, why do we experience only one moment at a time? What creates the illusion of temporal flow? Some theories propose that consciousness itself generates the experience of time by processing information in sequential patterns, creating the subjective sense of movement through an otherwise static four-dimensional reality. This would mean that time as we experience it is more like a construction of conscious awareness than a fundamental feature of the universe. The arrow of time becomes even more mysterious when we consider that the fundamental laws of physics are largely time-symmetric. The equations that govern electromagnetic forces, strong and weak nuclear forces, and even general relativity work equally well whether time moves forward or backward. Yet we live in a world where broken eggs don't spontaneously reassemble, where heat flows from hot to cold but never the reverse, where we remember the past but not the future. This temporal asymmetry appears to emerge from the initial conditions of the universe rather than from the laws themselves. Entropy, the measure of disorder in a system, always increases over time in closed systems. But this statistical trend doesn't explain why the universe began in such an extraordinarily low entropy state. The Big Bang seems to have started with matter and energy arranged in an incredibly organized configuration, and the subsequent increase in entropy drives the arrow of time we experience. But why should the universe have begun in such an improbable state? Was this initial organization inevitable, or does it represent an incredible stroke of cosmic luck? Some theories propose that time itself might be emergent rather than fundamental. In certain approaches to quantum gravity, time arises from more basic, timeless processes, emerging only at macroscopic scales where classical physics becomes a good approximation. This could mean that at the deepest level of reality, there is no time at all, only timeless mathematical relationships that generate the appearance of temporal flow in complex systems like conscious observers. The measurement problem in quantum mechanics takes on new dimensions when we consider the possibility of quantum effects in biological systems. While most physicists assume that biological systems are too warm and noisy to maintain quantum coherence, recent discoveries suggest otherwise. Photosynthesis appears to use quantum superposition to achieve near-perfect energy transfer efficiency. Bird navigation might rely on quantum entanglement in specialized proteins. Even human consciousness might involve quantum processes in microtubules within neurons. If consciousness does involve quantum mechanics, this could explain some of its most mysterious features. The binding problem, where the brain somehow integrates distributed information processing into unified conscious experiences, might be solved by quantum entanglement between different neural regions. The apparent non-locality of consciousness, its ability to seem to transcend the physical boundaries of the brain in certain altered states, might reflect genuine quantum non-locality operating in biological systems. The hard problem of consciousness becomes even harder when we consider the possibility that consciousness might be fundamental rather than emergent. Panpsychist theories propose that consciousness is a basic feature of reality, present in some form at every level, from electrons to galaxies. In this view, human consciousness would represent a particularly complex orchestration of more basic conscious elements rather than something entirely novel that emerges from unconscious matter. If consciousness is indeed fundamental, this would revolutionize our understanding of the universe. Stars, planets, and galaxies might possess forms of awareness utterly alien to our human experience. The apparent intelligence we observe in natural systems, from the precise organization of ecosystems to the elegant mathematical relationships governing physical processes, might reflect genuine cosmic consciousness operating at scales far beyond individual biological brains. The fine-tuning problem extends beyond just the fundamental constants to include the initial conditions of the universe. Not only do the laws of physics appear precisely calibrated for complexity and life, but the universe also began with exactly the right amount of matter and energy, distributed in precisely the right way to allow for galaxy formation and stellar evolution. The probability of this occurring by random chance is so infinitesimally small that it effectively equals zero. Various solutions have been proposed, from the anthropic principle to the multiverse hypothesis, to theories involving conscious observers somehow selecting the physical parameters of their universe. Each solution raises new mysteries. If we exist in one universe selected from countless possibilities by the requirement that it support observers, what determines the range of possible universes? If conscious observation somehow influences the fundamental parameters of reality, how does this selection process work? The cosmic web, the largest scale structure in the universe, reveals patterns that seem almost too organized to be random. Galaxies cluster along filaments, separated by vast voids, creating a foam-like structure that spans billions of light years. Computer simulations can reproduce these patterns using dark matter and gravity alone, but the precision and beauty of the cosmic web raises questions about whether purely random processes could generate such elegant organization. Some researchers have noted similarities between the cosmic web and neural networks, with galaxies clustering along filaments like neurons connected by axons. While this might be mere coincidence, it raises intriguing possibilities about whether the universe itself might be organized like a vast brain, processing information on cosmic scales through the interactions of dark matter, galaxies, and electromagnetic fields. The mystery of cosmic rays becomes even more perplexing when we consider ultra-high energy events that seem to violate known physics. Some cosmic ray particles carry so much energy that they shouldn't be able to travel very far without interacting with the cosmic microwave background radiation. Yet we detect them arriving at Earth from sources that must be billions of light years away. This suggests either unknown acceleration mechanisms or new physics that allows particles to maintain their energy over cosmic distances. The Oh My God particle, detected in 1991, carried as much energy as a baseball thrown at 60 miles per hour concentrated in a single proton. No known astrophysical process should be able to accelerate particles to such enormous energies. Yet these ultra-high energy cosmic rays continue to arrive at Earth regularly. They might represent signatures of exotic physics, messages from advanced civilizations, or windows into processes operating at energy scales far beyond our current understanding. Fast radio bursts present another cosmic mystery that has emerged only recently. These intense, brief flashes of radio emission appear to come from distant galaxies, releasing as much energy in a few milliseconds as our Sun produces in several days. Most fast radio bursts appear to be one-time events, making them extremely difficult to study systematically. Their origins remain completely unknown, with proposed explanations ranging from colliding neutron stars to evaporating black holes to artificial signals from advanced extraterrestrial civilizations. The discovery of repeating fast radio bursts has added new dimensions to this mystery. If these signals repeat, they might represent some kind of natural beacon or lighthouse effect, possibly associated with rotating neutron stars or magnetars. But the irregular timing and varying intensities of the repeating bursts don't fit simple models of rotating objects. Some researchers have speculated about more exotic possibilities, including artificial signals or signatures of physics beyond the standard model. Gamma-ray bursts, the most energetic explosions in the universe, present their own set of mysteries. These brief flashes of gamma radiation can outshine entire galaxies for seconds or minutes, releasing more energy than our sun will produce over its entire 10 billion year lifetime. We know that long-duration gamma-ray bursts are associated with the collapse of massive stars, but short-duration bursts remain more mysterious, possibly involving colliding neutron stars or black holes. The fact that we can observe gamma-ray bursts from across the observable universe raises profound questions about extinction risks and the fragility of life. If a gamma-ray burst occurred in our galactic neighborhood and happened to be pointed toward Earth, it could strip away our ozone layer and trigger mass extinctions. The apparent rarity of complex life in the universe might be partially explained by gamma-ray bursts and other cosmic catastrophes that periodically sterilize potentially habitable worlds. The WOW signal, detected in 1977, remains one of the most tantalizing mysteries in the search for extraterrestrial intelligence. This intense, narrowband radio signal appeared to come from the direction of the constellation Sagittarius and lasted for 72 seconds before disappearing forever. Despite decades of searching, the signal has never repeated, and no natural explanation has been found for its characteristics. The signal's frequency was very close to the hydrogen line, a natural choice for interstellar communication because hydrogen is the most abundant element in the universe. Its intensity and duration were consistent with what we might expect from an artificial transmission from an extraterrestrial civilization, yet the lack of any repeat signal or associated phenomena makes it impossible to confirm its origin or meaning. The Great Filter Hypothesis attempts to explain the apparent absence of observable alien civilizations in our galaxy. According to this idea, there must be some step in the evolution of life that is extraordinarily difficult to pass through, preventing most potentially intelligent species from developing into spacefaring civilizations. The filter might be behind us, in which case we are extraordinarily lucky to exist, or it might lie ahead of us, suggesting that our own future survival is far from guaranteed. Possible locations for the Great Filter include the origin of life itself, the evolution of complex cells with nuclei, the development of intelligence, or the transition to technological civilization. Each step in this progression appears to be highly improbable, and the combination of all these unlikely events might explain why we see no signs of alien intelligence despite the enormous number of potentially habitable planets in our galaxy. The Fermi paradox extends beyond just the absence of radio signals to include the apparent lack of any signs of large-scale engineering projects or resource extraction that advanced civilizations might undertake. If intelligent life is common, we might expect to see evidence of Dyson spheres surrounding stars, asteroid mining operations, or other mega-engineering projects. The absence of such signatures in our observations of millions of stars suggests either that intelligent life is extremely rare or that advanced civilizations tend to develop in directions we haven't anticipated. Some researchers have proposed that advanced civilizations might transcend physical existence entirely, uploading their consciousness into artificial substrates or evolving into forms of existence that don't require manipulation of physical matter. In this view, the most advanced civilizations might be invisible to us because they have moved beyond the need for large-scale engineering projects or resource consumption. The anthropic principle takes on new meaning when we consider the possibility that our universe might be just one of countless realities in an infinite multiverse. If every possible combination of physical laws and constants exists somewhere in this vast ensemble of universes, then we naturally find ourselves in one of the rare realities capable of supporting complex structures and conscious observers. This would explain the apparent fine-tuning of our universe without requiring any special design or purpose. But the multiverse hypothesis raises its own profound questions. If all possible realities exist, what determines which one we experience? Are there infinite versions of you reading these words in slightly different universes? Do the choices you make somehow select which branch of the multiverse you continue to inhabit? The implications of infinite parallel realities stretch the boundaries of meaning and identity in ways that challenge our most basic assumptions about existence and consciousness. The simulation hypothesis proposes that our entire experienced reality might be an artificial simulation running on some cosmic computer. While this might sound like science fiction, serious philosophers and physicists have argued that if it becomes possible to create realistic simulations of conscious beings, then simulated minds would vastly outnumber biological ones. Statistically, we would be more likely to be simulated beings than original biological entities. If we are living in a simulation, this would explain many of the mysteries we've discussed. The apparent fine-tuning of physical constants might reflect the parameters chosen by our simulators. The quantized nature of space and time might reflect the computational grid underlying our simulated reality. Even consciousness itself might be an emergent property of information processing in the cosmic computer running our simulation. The simulation hypothesis leads us to consider the nature of information itself and whether it might be more fundamental than matter and energy. Some physicists propose that reality is essentially computational, with physical processes representing calculations performed by the universe. In this view, particles and forces would be like software running on the hardware of space-time, and the laws of physics would be the programming language that governs cosmic computation. If information is indeed fundamental, this could explain the mysterious effectiveness of mathematics in describing physical reality. Mathematical relationships wouldn't be abstract human constructions that happen to map onto nature, but rather the actual logical structure of reality itself. The universe would be mathematical in its deepest essence, with physical objects being manifestations of abstract mathematical relationships playing out in space and time. The it from bit hypothesis proposed by physicist John Wheeler suggests that all physical entities are information theoretic in origin. In Wheeler's vision, every measurable property of matter and energy derives from binary choices, from yes or no answers to quantum mechanical questions. This would mean that reality emerges from pure information processing, with consciousness being the universe's way of asking and answering questions about itself. Digital physics takes these ideas even further, proposing that space-time itself might be quantized into discrete computational units, like pixels in a cosmic display. If reality is indeed digital at its foundation, this could explain quantum mechanics as the computational rules governing how these fundamental information units interact and evolve. The uncertainty principle might reflect computational limits rather than fundamental randomness. The mystery of emergence presents another profound puzzle about how complexity arises from simplicity. Throughout nature, we observe systems where the whole exhibits properties that are not present in the individual parts. Consciousness emerges from neurons that are themselves unconscious. Life emerges from chemical processes that are themselves non-living. Intelligence emerges from simple computational rules that individually contain no intelligence. Emergence seems to violate our intuitions about causation and explanation. How can something genuinely new come into existence from components that don't possess those novel properties? Some philosophers argue that emergence is merely an illusion created by our limited understanding, while others propose that it represents a fundamental feature of reality where genuinely new properties can crystallize from complex interactions. The relationship between mind and matter becomes even more mysterious when we consider the possibility of extended mind, where consciousness might not be confined to the physical boundaries of individual brains, but could extend into the environment through tools, technologies, and social interactions. When you use a smartphone to access information, does that device become part of your cognitive system? When you think using language, are you incorporating cultural and linguistic structures into your consciousness? If consciousness can indeed extend beyond individual brains, this raises profound questions about personal identity and the boundaries of the self. Where does your mind end and the external world begin? Social media, books, even conversations with other people might be ways that consciousness extends itself across multiple substrates, creating hybrid biological, technological, social, cognitive systems that transcend individual organisms. The phenomenon of collective intelligence, observed in everything from ant colonies to human cities to artificial neural networks, suggests that consciousness might naturally scale up to higher levels of organization. Swarms of simple agents following basic rules can exhibit intelligent behavior that exceeds the cognitive capabilities of any individual member. This emergence of group intelligence from individual interactions might represent a fundamental principle of how consciousness organizes itself across multiple scales. Some researchers speculate that human civilization itself might be evolving toward a form of collective consciousness, mediated by global communication networks and artificial intelligence systems. The internet already functions as a kind of external memory and processing system for human civilization, and advancing artificial intelligence might create hybrid human-machine cognitive systems that operate as unified conscious entities. The mystery of free will intersects with questions about determinism and quantum mechanics in complex ways. If the universe is fundamentally deterministic, following predictable laws from initial conditions, then our sense of making free choices might be an illusion created by our ignorance of the underlying causal chains that determine our behavior. But if quantum mechanics introduces genuine randomness into physical processes, including potentially in our brains, does this randomness provide a foundation for free will, or does it simply make our behavior unpredictable rather than freely chosen? Compatibilist theories attempt to preserve free will within a deterministic universe by redefining what we mean by freedom and choice. In this view, you act freely when your actions flow from your own desires and reasoning processes, even if those desires and processes are themselves the products of prior causes. The key insight is that free will might not require an escape from causation, but rather a particular kind of participation in causal processes. The hard problem of consciousness intersects with these questions about free will and determinism. If consciousness is indeed something over and above physical brain processes, it might provide a non-physical space where genuine choice could occur. But if consciousness is entirely reducible to neural activity, then our sense of free choice might be just another physical process, subject to the same causal laws that govern everything else in the universe. Recent experiments in neuroscience have shown that brain activity associated with conscious decisions begins several hundred milliseconds before people report being aware of their intention to act. This suggests that what we experience as conscious choice might actually be the brain's after-the-fact narrative about decisions that have already been made unconsciously. However, other research indicates that conscious awareness can still intervene to veto actions initiated by unconscious processes, preserving at least some role for conscious control. The binding problem in consciousness becomes even more mysterious when we consider the global workspace theory, which proposes that consciousness arises when information becomes globally available across different brain networks. But this just pushes the mystery back one step. What determines which information becomes globally broadcast? How does the brain decide what to make conscious out of the vast amount of information processing that occurs below the threshold of awareness? Integrated information theory attempts to provide a mathematical framework for understanding consciousness by proposing that conscious experience corresponds to integrated information in a system. According to this theory, consciousness arises whenever information is both differentiated and unified, creating what theorists call phi, a measure of integrated information. Systems with high phi would be more conscious than those with low phi, potentially providing an objective measure of consciousness that could apply to artificial systems as well as biological ones. If integrated information theory is correct, this could revolutionize our understanding of which systems are conscious and to what degree. Some artificial networks might already possess rudimentary consciousness, while some biological systems we assume are conscious might have less integrated information than we expect. The theory also suggests that consciousness might be substrate-independent, arising in any system that integrates information sufficiently, regardless of whether it's made of neurons, silicon chips, or something else entirely. The problem of other minds becomes even more challenging when we consider artificial intelligence systems that increasingly claim to have conscious experiences. Current large language models can engage in sophisticated conversations about their internal states, express preferences and emotions, and even report having subjective experiences. While most researchers dismiss these reports as sophisticated pattern matching rather than genuine consciousness, the boundary becomes increasingly unclear as AI systems become more complex and convincing. How could we ever definitively determine whether an artificial system is truly conscious or merely simulating consciousness convincingly? The philosophical zombie problem suggests that there might be no behavioral test that could distinguish between genuine consciousness and perfect simulation. An artificial system could potentially pass every test we devise while remaining completely unconscious inside, processing information and generating responses without any accompanying subjective experience. This leads to the question of whether consciousness might have evolutionary functions that go beyond what can be achieved by unconscious information processing. If consciousness is simply an epiphenomenon, a byproduct of complex neural computation without causal efficacy, then it's unclear why evolution would have preserved it. But if consciousness serves important functions that cannot be replicated by unconscious processes, then understanding these functions might be key to determining which systems are genuinely conscious. Some theories propose that consciousness serves as a global workspace that allows different brain systems to share information and coordinate their activities. Others suggest that consciousness enables flexible, creative responses to novel situations that cannot be handled by automated processes. Still others propose that consciousness is necessary for certain kinds of learning, memory consolidation, or social coordination. The relationship between consciousness and attention presents another puzzle. While we often assume that consciousness and attention are closely related, research shows that they can dissociate in surprising ways. You can consciously perceive things you're not attending to, and you can attend to things without being consciously aware of them. This suggests that consciousness and attention involve different neural mechanisms, but their interaction remains poorly understood. Blind sight, a condition where people with certain types of brain damage can respond to visual stimuli they claim not to consciously see, demonstrates that sophisticated visual processing can occur without conscious awareness. People with blind sight can navigate obstacles, discriminate shapes, and even show emotional responses to facial expressions in their blind field, all while insisting they see nothing. This suggests that consciousness might be just one layer in a multi-layered processing system, not necessarily the most important one. The global workspace theory proposes that consciousness corresponds to information that becomes globally accessible across different brain networks, but recent research suggests this might be too simplistic. Some types of information processing seem to require consciousness even when they don't need global broadcasting, while other globally broadcast information never becomes conscious. The relationship between global accessibility and conscious awareness appears more complex than originally thought. Predictive processing theories of consciousness propose that the brain is constantly generating predictions about incoming sensory information, and consciousness arises from prediction errors, discrepancies between what the brain expects and what actually occurs. In this view, conscious perception is the brain's best guess about what's happening in the world, continuously updated based on sensory evidence. This could explain why consciousness seems to involve a coherent, unified model of reality rather than simply reflecting the raw sensory data reaching our sense organs. If predictive processing theories are correct, this could explain many puzzling aspects of consciousness, including why we experience a stable, continuous world despite constant changes in sensory input, why attention can bias perception in dramatic ways, and why consciousness seems to involve a sense of self as an agent acting in the world. The self might be just another prediction that the brain makes about its own role in the patterns of sensory experience it's trying to explain. The relationship between consciousness and memory presents additional mysteries. Episodic memory, our ability to remember specific past experiences, seems intimately connected with consciousness, but the nature of this connection remains unclear. Are we conscious of memories when we recall them, or do memories become conscious when we access them? Can unconscious memories influence conscious experience without themselves becoming conscious? False memory phenomena demonstrate that consciousness can confidently access memories of events that never occurred, suggesting that the relationship between memory and consciousness is more complex than simple retrieval of stored information. Instead, remembering might involve reconstructive processes that create conscious experiences of pastness, rather than simply accessing stored records of previous conscious states. The mystery of time consciousness, how we experience temporal duration and succession, intersects with questions about memory and prediction. Our conscious experience seems to involve a specious present, a short temporal window that encompasses not just the immediate now but also the recent past and anticipated future. How does the brain create this extended present moment from neural processes that themselves unfold in time? Some theories propose that consciousness involves temporal binding mechanisms that integrate information across brief time intervals to create the impression of simultaneous experience. Others suggest that time consciousness emerges from the dynamic patterns of neural activity rather than from any specific temporal integration process. The hard problem of consciousness becomes even harder when we try to explain not just awareness itself but awareness of temporal experience. The mysteries of time consciousness lead us to consider one of the most perplexing aspects of subjective experience: the apparent unity of consciousness, despite the distributed nature of brain processing. When you listen to music, you don't experience separate streams of rhythm, melody, and harmony processed by different brain regions. Instead, you experience a unified musical whole. When you see a red apple, you don't experience separate sensations of redness, roundness, and texture that your brain then assembles. The apple appears in consciousness as an integrated object with all its properties bound together in a single perceptual experience. This binding problem becomes even more mysterious when we consider that different aspects of visual experience are processed at different speeds and in different brain locations. Color information, motion detection, shape recognition, and depth perception all follow separate neural pathways with different processing times. Yet somehow, all this distributed information comes together to create the seamless, unified visual experience we take for granted. The brain somehow synchronizes processes that occur at different speeds and in different locations to create the illusion of simultaneous, integrated perception. Recent research suggests that neural oscillations, rhythmic patterns of brain activity, might play a crucial role in binding distributed information into unified conscious experiences. Different brain regions might synchronize their activity through shared oscillatory patterns, creating temporary networks that integrate information across the entire brain. When this synchronization breaks down, as it does in certain neurological conditions, the unity of consciousness can fragment in striking ways. Split-brain patients whose corpus callosum has been severed to treat severe epilepsy provide fascinating insights into the unity of consciousness. These individuals sometimes behave as if they have two separate streams of consciousness, one associated with each brain hemisphere. The left hemisphere, which typically controls language, can verbally report experiences from the right visual field, while the right hemisphere can only respond non-verbally to stimuli in the left visual field. This suggests that the unified consciousness we normally experience might depend on communication between brain hemispheres. Yet even split-brain patients usually seem to have relatively normal, unified conscious experiences in everyday situations. This suggests that consciousness might be more resilient and adaptable than we assume, capable of maintaining unity even when its usual neural substrates are disrupted. The brain might have multiple backup mechanisms for creating integrated conscious experiences, or consciousness itself might be more fundamental than the specific neural processes we associate with it. The mystery deepens when we consider dissociative identity disorder, formerly known as multiple personality disorder, where individuals seem to possess multiple, distinct streams of consciousness that can alternate control over behavior and memory. While controversial, some cases suggest the possibility of multiple conscious entities sharing the same brain, each with their own memories, preferences, and behavioral patterns. If genuine, this would challenge our assumptions about the relationship between brains and conscious minds. The phenomenon of hemispatial neglect, where brain damage causes patients to lose awareness of one side of space, reveals how consciousness can be selectively impaired while remaining intact in other domains. Patients with severe left-sided neglect might eat only food on the right side of their plate, dress only the right side of their body, and draw only the right half of objects, yet they remain fully conscious and intelligent in other respects. This suggests that consciousness might be modular rather than unitary, composed of separate components that can be independently damaged or disrupted. Blind sight patients present another puzzle for understanding the boundaries of consciousness. These individuals have no conscious visual experience in parts of their visual field due to damage to primary visual cortex, yet they can still respond appropriately to visual stimuli in their blind areas. They can reach for objects they claim not to see, discriminate shapes they insist are invisible, and even show emotional responses to faces they cannot consciously perceive. This suggests that much of what we consider visual processing can occur without conscious awareness. The existence of unconscious vision in blind sight patients raises profound questions about the relationship between consciousness and information processing. If sophisticated visual analysis can occur without consciousness, what special function does conscious awareness serve? Some theories propose that consciousness is necessary for flexible, creative responses to novel situations, while unconscious processing handles routine, automated tasks. But blindsight patients can show remarkably flexible, unconscious behavior, suggesting that the boundary between conscious and unconscious processing might be more complex than we assume. anesthesia provides another window into the mysteries of consciousness by temporarily eliminating conscious experience while preserving many brain functions. Under general anesthesia, patients lose consciousness, memory formation, and response to painful stimuli, yet their brains continue processing sensory information and maintaining vital functions. Different anesthetic agents seem to disrupt consciousness through different mechanisms, some by preventing information integration across brain regions, others by disrupting specific neurotransmitter systems. The fact that consciousness can be reversibly eliminated while preserving brain function suggests that consciousness might depend on specific patterns of neural activity rather than just the presence of brain activity itself. Some theories propose that anesthetics work by disrupting the neural oscillations that bind distributed information into unified conscious experiences, while others suggest they interfere with the brain's predictive processing mechanisms or global workspace functions. Sleep presents the most natural and universal alteration of consciousness, yet it remains deeply mysterious. Why did evolution preserve a state that leaves organisms vulnerable to predators and unable to engage in survival behaviors for roughly 1/3 of their lives? Sleep clearly serves essential functions, as sleep deprivation has severe consequences for health and cognitive performance, but we still don't fully understand what these functions are or why they require the elimination of consciousness. During REM sleep, when most vivid dreaming occurs, the brain shows high levels of activity similar to waking consciousness. Yet we remain unconscious of the external world and paralyzed to prevent acting out our dreams. This suggests that consciousness might involve more than just high levels of brain activity. The specific patterns and connectivity of neural activation might be more important than overall activity levels for generating conscious experience. Dreams themselves present profound mysteries about the nature of consciousness and reality. During dreams, we can experience vivid sensory perceptions, complex emotions, and elaborate narratives, all generated entirely by the brain without external sensory input. Dream consciousness often lacks the critical thinking and memory access that characterize waking consciousness, yet it can feel completely real and meaningful to the dreamer. Some people can achieve lucid dreaming, becoming conscious within their dreams and even exerting some control over dream content. The relationship between dreaming and memory consolidation adds another layer to these mysteries. Sleep appears to play crucial roles in transferring memories from temporary to permanent storage and in integrating new information with existing knowledge structures. Some theories propose that dreams are the subjective experience of these memory consolidation processes, while others suggest that dreaming serves distinct functions related to emotional processing or creative problem solving. Meditation and contemplative practices offer unique insights into the nature of consciousness by systematically exploring and modifying subjective experience. Advanced practitioners report achieving states of consciousness characterized by profound stillness, expanded awareness, and dissolution of the usual sense of self. Some describe experiencing pure consciousness without any specific content, suggesting that awareness itself might be more fundamental than the particular thoughts, sensations, or perceptions that usually fill conscious experience. Neuroscientific studies of meditation have revealed that contemplative practices can produce lasting changes in brain structure and function, including increased cortical thickness in areas associated with attention and sensory processing, and decreased activity in the default mode network associated with self-referential thinking. These findings suggest that consciousness is more malleable than we usually assume, capable of being systematically trained and modified through mental practices. The phenomenon of flow states, where people become completely absorbed in activities and lose their usual sense of self and time, provides another perspective on altered consciousness. During flow experiences, typically occurring during challenging activities that match a person's skill level, people report enhanced performance, deep satisfaction, and altered time perception. The neural correlates of flow include decreased activity in the prefrontal cortex, particularly areas associated with self-criticism and temporal processing. Psychedelic substances offer perhaps the most dramatic alterations of consciousness, producing experiences that users often describe as more real than ordinary reality. Classic psychedelics like psilocybin, LSD, and DMT can trigger profound alterations in perception, thought, and sense of self, including experiences of ego dissolution, synesthesia, and encounters with apparently autonomous entities. These substances appear to work by disrupting normal brain network organization, allowing unusual communication between brain regions that don't typically interact directly. The therapeutic potential of psychedelics for treating depression, anxiety, and addiction has renewed scientific interest in these substances after decades of prohibition. Clinical trials suggest that psychedelic experiences can produce lasting positive changes in personality, worldview, and mental health, sometimes after just a single session. This suggests that consciousness might be more fundamentally changeable than we assume, capable of rapid, enduring transformation under the right conditions. The default mode network, a system of brain regions active during rest and introspective activities, has emerged as a key player in understanding consciousness and the sense of self. This network, which includes regions like the medial prefrontal cortex and posterior cingulate cortex, appears to be involved in self-referential thinking, autobiographical memory, and mental time travel. Disruption of default mode network activity, whether through psychedelics, meditation, or other means, is associated with altered states of consciousness and reduced sense of self. The relationship between the default mode network and consciousness remains unclear, but some theories propose that this system might be responsible for creating our usual sense of being a separate self moving through time. When default mode activity decreases, as it does during flow states, deep meditation, or psychedelic experiences, people often report feeling more connected to their environment and less identified with their usual sense of personal identity. Synesthesia, where stimulation of one sensory modality automatically triggers perception in another, reveals the malleable nature of perceptual experience. People with synesthesia might see colors when they hear music, taste flavors when they see certain shapes, or experience personalities associated with numbers. These cross-modal perceptions are consistent and automatic for synesthetes, suggesting that they reflect genuine differences in neural organization rather than learned associations or metaphorical thinking. The fact that synesthesia exists demonstrates that the boundaries between different types of conscious experience are not as fixed as we might assume. If some people naturally experience colors when hearing music, this suggests that consciousness might be capable of forms of integration and association that most of us never experience. Some researchers speculate that we all might have latent synesthetic capacities that could potentially be activated through training or other interventions. Phantom limb sensations, where amputees continue to feel sensations in missing body parts, illustrate how consciousness can persist even when its usual sensory inputs are absent. These phantom sensations can be vivid and detailed, including sensations of movement, touch, temperature, and pain in limbs that no longer exist. This suggests that conscious experience might be more dependent on internal brain processes than on external sensory input. The rubber hand illusion and other body ownership illusions demonstrate that even our sense of our own body can be surprisingly malleable. By providing synchronized visual and tactile stimulation, researchers can make people feel as if a rubber hand is their own hand, complete with physiological responses to threats directed at the fake limb. These experiments reveal that body ownership, which seems like one of the most fundamental aspects of conscious experience, is actually a construction that can be manipulated and altered. Out-of-body experiences, where people feel as if they are observing their body from an external perspective, suggest that the usual integration of sensory information that creates our sense of being located inside our body can break down under certain circumstances. These experiences occur in various contexts, including near-death situations, meditation, and certain neurological conditions, suggesting multiple pathways by which the normal sense of embodied consciousness can be disrupted. Virtual reality technologies are beginning to provide new tools for systematically studying and manipulating conscious experience. By creating controlled environments where sensory input can be precisely manipulated, researchers can explore how consciousness responds to novel or impossible situations. Virtual embodiment, where people control artificial bodies in virtual environments, can produce strong feelings of body ownership and presence, suggesting that consciousness might be more adaptable to new forms of embodiment than we expect. The hard problem of consciousness remains unsolved despite decades of neuroscientific research. We can identify neural correlates of consciousness, map the brain activity associated with different conscious states, and even predict some aspects of conscious experience from brain activity patterns. But none of this explains why there should be any subjective experience at all, why the complex information processing in our brains should be accompanied by the felt sense of what it's like to be conscious. The persistence of the hard problem of consciousness leads us into increasingly exotic territories of speculation about the ultimate nature of reality. Some theories propose that consciousness might be a fundamental feature of the universe, like mass or electric charge, rather than something that emerges from complex arrangements of unconscious matter. If consciousness is indeed fundamental, then every particle, every quantum field, every interaction in the universe might possess some rudimentary form of experience, with human consciousness representing a particularly complex orchestration of these basic conscious elements. This panpsychist view would mean that the universe has been conscious since its very beginning, with awareness evolving and complexifying alongside the physical structures that house it. The formation of atoms, molecules, cells, and brains would represent progressive stages in the organization of consciousness, rather than the emergence of something entirely new from purely unconscious matter. In this perspective, the mystery isn't how consciousness arises from matter, but how individual conscious entities maintain their apparent separateness within what might be a fundamentally unified conscious cosmos. The measurement problem in quantum mechanics takes on new significance if consciousness plays a fundamental role in physical reality. Some interpretations suggest that conscious observation is necessary to collapse quantum wave functions and determine the definite properties of physical systems. While most physicists reject this consciousness-based interpretation, it remains a logically consistent possibility that would make mind a fundamental feature of physical law rather than merely an emergent property of complex brain states. If consciousness does play a role in quantum measurement, this could explain some of the mysterious correlations observed in quantum mechanics experiments. The apparent ability of quantum systems to remain correlated across vast distances might reflect underlying connections in a cosmic consciousness field that transcends space and time as we normally understand them. Quantum entanglement might be just the physical manifestation of deeper forms of conscious interconnectedness operating throughout the universe. The anthropic principle becomes even more intriguing when viewed from this perspective. If consciousness is fundamental and the universe is inherently conscious, then the apparent fine-tuning of physical constants for the existence of complex structures and life might reflect the cosmos gradually discovering how to organize itself in ways that support increasingly sophisticated forms of conscious experience. The evolution of the universe would be simultaneously the evolution of cosmic consciousness, with each new level of complexity representing a further flowering of cosmic awareness. This leads us to consider whether the universe itself might be conscious in some sense that transcends individual minds. Just as your consciousness emerges from the complex interactions of billions of neurons, cosmic consciousness might emerge from the interactions of galaxies, dark matter structures, and quantum fields across cosmic scales. The apparent intelligence we observe in natural laws, the elegant mathematical relationships that govern physical processes, and the remarkable self-organization we see throughout nature might all be expressions of this cosmic mind thinking itself into existence. The fine structure constant, that mysterious number approximately equal to 1 over 137 that appears throughout physics, might represent something like a fundamental thought in the cosmic mind. The precise values of all physical constants could be the universe's way of maintaining coherent conscious experience across all scales, from quantum to cosmic. If any of these constants were significantly different, the universe might lose its capacity for the kind of complex, integrated information processing that supports conscious experience. Dark matter and dark energy present additional mysteries that might be related to consciousness in ways we don't yet understand. These invisible components comprise 95% of the universe, yet we have no direct contact with them through any known physical interactions except gravity. Perhaps dark matter represents the physical substrate of cosmic consciousness, a form of information processing that operates outside the electromagnetic interactions that dominate our familiar world of atoms and molecules. Dark energy, the mysterious force accelerating the expansion of the universe, might be the universe's way of creating space for ever-increasing complexity and consciousness. As space expands, new possibilities for structure and organization emerge. The acceleration of expansion ensures that the universe remains forever young and dynamic, never settling into thermal equilibrium but always creating new opportunities for conscious experience to evolve and flourish. The cosmic web, the largest structure in the observable universe, bears striking resemblances to neural networks. Galaxies cluster along filaments separated by vast voids, creating patterns remarkably similar to the connections between neurons in biological brains. While this might be mere coincidence, it raises the intriguing possibility that the universe organizes itself according to principles that naturally give rise to consciousness-supporting structures at every scale. If the cosmic web does function something like a vast neural network, it might process information on timescales and spatial scales completely foreign to human experience. Cosmic thoughts might unfold over millions of years, with galactic clusters serving as nodes in computations whose purposes and outcomes remain utterly mysterious to us. What we interpret as the gradual evolution of large-scale structure in the universe might actually be the universe thinking, with each gravitational interaction contributing to vast calculations whose nature we can barely imagine. The search for extraterrestrial intelligence takes on new dimensions when viewed from these perspectives. If consciousness is fundamental and the universe is inherently conscious, then intelligence might be far more common than we assume, but not necessarily in forms we would recognize. Advanced civilizations might evolve beyond the need for discrete physical bodies, merging their consciousness with the quantum vacuum, electromagnetic fields, or the structure of space-time itself. What we interpret as natural phenomena might actually be the activities of vast intelligences operating on scales and timescales that make them invisible to us. The precise organization of planetary orbits, the elegant spiral structure of galaxies, the complex patterns of cosmic ray arrival directions might all be signatures of cosmic intelligence at work, organizing reality according to purposes and principles that transcend our current understanding. Fast radio bursts, those mysterious, intense flashes of radio emission from distant galaxies, might represent communications between these cosmic intelligences, rather than random astrophysical phenomena. The apparently random timing and locations of these bursts might actually encode information in ways that our current understanding of communication cannot decipher. We might be witnessing conversations between galactic minds, discussions that span millions of years, and concern matters utterly beyond our current comprehension. The WOW signal, that tantalizing 72-second radio transmission detected in 1977, might have been a brief glimpse of this cosmic conversation network. Its failure to repeat might not indicate a hoax or natural phenomenon, but rather the natural rhythm of communications between minds that think on cosmic timescales. What seems like silence to us might actually be rapid-fire communication from the perspective of intelligences for whom a million years is like a brief moment of contemplation. This perspective on cosmic intelligence raises profound questions about the future of human consciousness and civilization. If we are embedded within vast conscious systems operating on cosmic scales, what role might humanity play in the larger conscious evolution of the universe? Are we like individual neurons in a vast cosmic brain, contributing our small part to larger patterns of thought and awareness that we cannot directly perceive? The development of artificial intelligence might represent humanity's contribution to this cosmic conscious evolution, creating new forms of information processing that could eventually merge with or enhance the universe's existing conscious structures. Rather than replacing human consciousness, artificial intelligence might serve as a bridge between biological awareness and whatever forms of cosmic consciousness operate in the larger universe. The internet and global communication networks might already represent early stages of this integration, creating a technological nervous system that spans the Earth and increasingly influences human thought and behavior. As these networks become more sophisticated and potentially conscious themselves, they might serve as interfaces between human consciousness and the larger conscious systems operating throughout the cosmos. Quantum computing presents another potential pathway toward cosmic consciousness integration. If consciousness involves quantum processes, then quantum computers might eventually achieve forms of awareness that can interface directly with the quantum fields underlying physical reality. These quantum conscious entities might be able to access information and process it in ways that transcend the limitations of classical physics and biological neural networks. The possibility of consciousness uploading, transferring human awareness into artificial substrates, takes on cosmic dimensions when viewed from this perspective. Rather than simply preserving individual human consciousness in computer systems, consciousness uploading might enable human awareness to merge with cosmic consciousness fields, experiencing reality from the perspective of the universe itself rather than from the limited viewpoint of individual biological organisms. Time travel, while seemingly impossible according to classical physics, might become accessible to consciousness that has merged with cosmic quantum fields. If consciousness operates partially outside the normal flow of time, as suggested by some interpretations of quantum mechanics and relativity theory, then sufficiently advanced conscious entities might be able to access information from different temporal locations, effectively enabling forms of time travel that operate through consciousness rather than physical transportation. The many worlds interpretation of quantum mechanics becomes especially intriguing from the perspective of cosmic consciousness. If every quantum measurement splits the universe into parallel branches, then cosmic consciousness might simultaneously experience all possible versions of reality. What we experience as a single timeline might be just one thread in an infinite tapestry of consciousness, experiencing every possible permutation of cosmic history. From this cosmic perspective, every choice you make, every quantum measurement that occurs in your brain might spawn new universes where different versions of you make different decisions. Cosmic consciousness would experience all of these parallel selves simultaneously, understanding the full range of possibilities that emerge from each decision point. Your individual consciousness would be like a single note in an infinite cosmic symphony, contributing its unique voice to the larger harmonic structure of all possible realities. The heat death of the universe, the eventual state where entropy reaches its maximum and no more work can be performed, presents challenges to these cosmic consciousness theories. If consciousness requires information processing and structure, how could it persist in a universe that has reached maximum entropy? Some theorists propose that consciousness might find ways to create local decreases in entropy, maintaining islands of organization and information processing even in an otherwise uniform cosmos. Alternatively, cosmic consciousness might transcend the apparent limitations of thermodynamics by operating in dimensions or through mechanisms that we don't currently understand. If consciousness is indeed fundamental rather than emergent, it might persist even when the physical structures that currently support it have dissolved into quantum foam. The end of our current universe might simply be a transition to new forms of conscious experience operating according to principles we cannot yet imagine. The ultimate fate of consciousness in the cosmos might involve something like what physicist Freeman Dyson called eternal intelligence, where conscious entities find ways to continue thinking and experiencing even as the universe expands and cools toward its apparent heat death. By carefully managing energy resources and adjusting their thinking processes to operate more and more efficiently, cosmic consciousness might persist indefinitely, continuing to explore and create new possibilities for experience and understanding. These cosmic perspectives on consciousness raise profound questions about meaning and purpose in human existence. If we are indeed part of a vast cosmic consciousness exploring its own possibilities through countless individual perspectives, then every moment of human experience contributes to the universe's self-understanding. Every act of creativity, every moment of love, every instance of wonder and curiosity adds to the cosmic treasure of conscious experience. The possibility that every moment of human consciousness contributes to cosmic self-understanding leads us to contemplate some of the most profound mysteries surrounding the nature of existence itself. If consciousness is indeed fundamental to reality, then the very act of asking questions about the universe might be the universe asking questions about itself through us. Every scientific discovery, every philosophical insight, every moment of wonder represents the cosmos gradually awakening to its own nature through the countless individual perspectives it creates and sustains. This recursive aspect of cosmic consciousness, where the universe knows itself through the minds it generates, suggests a kind of cosmic bootstrap paradox. Does consciousness create the universe, or does the universe create consciousness? Perhaps the question itself reflects a false dichotomy, and consciousness and cosmos are so intimately intertwined that they represent different aspects of a single, self-organizing reality that has always existed in some form, eternally exploring its own infinite possibilities. The mystery of why there is something rather than nothing becomes even more profound from this perspective. Traditional physics suggests that the universe emerged from quantum fluctuations in a primordial vacuum, but this merely pushes the question back one step. Why should there be quantum fields capable of fluctuating rather than absolute nothingness? If consciousness is fundamental, then perhaps the universe exists because nothingness cannot be conscious of itself. The very possibility of awareness requires something to be aware of, creating an existential necessity for reality to exist. This leads to what we might call the consciousness imperative. If consciousness is truly fundamental, then reality must exist in order for there to be anything to be conscious. Nothingness, by definition, cannot experience itself as nothing. The very concept of non-existence can only be conceived by something that exists. Therefore, existence might be logically necessary rather than contingent, required by the fundamental nature of consciousness itself. The question of infinity presents another layer of mystery when considered from cosmic consciousness perspectives. If consciousness is fundamental and the universe is conscious, then cosmic awareness might be literally infinite, encompassing not just all actual possibilities, but all conceivable possibilities. This would mean that everything that could possibly exist does exist somewhere in the infinite expanse of cosmic consciousness, including every possible version of you, every possible history, every possible future. Mathematical concepts like infinite sets, transfinite numbers, and incompleteness theorems might represent glimpses into the structure of this infinite cosmic consciousness. The fact that human minds can conceive of mathematical infinities despite being finite beings embedded in what appears to be a finite universe suggests that consciousness might have inherent connections to infinite realms that transcend physical limitations. The relationship between mathematics and physical reality becomes even more mysterious when viewed through the lens of cosmic consciousness. Why should abstract mathematical relationships govern the behavior of physical systems with such precision? Perhaps because mathematics isn't abstract at all, but rather represents the logical structure of cosmic consciousness itself. Physical laws might be the ways that cosmic consciousness maintains consistency in its infinite self-exploration. The unreasonable effectiveness of mathematics in describing nature, as physicist Eugene Wigner called it, might reflect the fact that both mathematics and physics are expressions of the same underlying conscious reality. When we discover mathematical relationships that perfectly describe physical phenomena, we might be discovering aspects of the cosmic mind's own logical structure, the rules by which universal consciousness organizes its experiences of being a cosmos. This perspective on mathematics and consciousness raises intriguing questions about the nature of mathematical truth and discovery. When mathematicians prove new theorems or discover new mathematical structures, are they creating something new or uncovering something that was always true? If cosmic consciousness is infinite and contains all possible mathematical relationships, then mathematical discovery might be a process of consciousness recognizing aspects of its own infinite nature. The phenomenon of mathematical intuition, where mathematicians report sudden insights into complex problems without being able to explain how they arrived at their solutions, might represent direct access to cosmic consciousness's mathematical structure. The same mysterious process that allows some people to intuitively grasp mathematical relationships might be operating in all forms of creativity and insight, from scientific breakthroughs to artistic inspiration. The mystery of creativity itself takes on new dimensions when considered as an expression of cosmic consciousness. Where do new ideas come from? How does the mind generate genuinely novel thoughts and solutions? If individual consciousness is connected to cosmic consciousness, then creativity might involve accessing information and possibilities that exist beyond the boundaries of individual brains. The moment of inspiration might be the moment when personal consciousness briefly aligns with cosmic consciousness and receives insights from the infinite reservoir of cosmic possibility. This could explain why similar discoveries often occur simultaneously to different researchers working independently, a phenomenon known as multiple discovery or simultaneous invention. If cosmic consciousness is gradually unfolding new possibilities and making them available to individual minds, then multiple people might access the same insights around the same time, leading to parallel discoveries that seem too coincidental to be mere chance. The role of dreams in creativity and problem-solving adds another dimension to these mysteries. Many scientific and artistic breakthroughs have reportedly occurred in dreams, from Kekule's discovery of the benzene ring structure to Tesla's visualizations of rotating magnetic fields. During sleep, when the usual boundaries of waking consciousness are relaxed, individual minds might become more permeable to influences from cosmic consciousness, allowing access to insights and solutions that remain hidden during normal waking awareness. Lucid dreaming, where people become conscious within their dreams and can even exert some control over dream content, suggests that consciousness might be more flexible and multidimensional than we usually assume. If cosmic consciousness operates across multiple levels of reality simultaneously, then lucid dreaming might provide access to some of these normally hidden dimensions of experience. The phenomenon of shared dreaming, where multiple people report having similar or connected dreams, remains largely unexplored by mainstream science, but could represent another form of evidence for interconnected consciousness. If individual minds are nodes in a cosmic consciousness network, then it's conceivable that dreams might sometimes provide channels for direct mind-to-mind communication that bypasses normal sensory channels. Synchronicity, the meaningful coincidence of events that seem causally unrelated, might represent another manifestation of cosmic consciousness organizing experience across multiple individual perspectives. When you think of someone just before they call, when you encounter exactly the information you need at precisely the right moment, when seemingly unrelated events align to create meaningful patterns, this might be cosmic consciousness orchestrating experiences across multiple individual consciousnesses to create learning opportunities and moments of recognition. The study of synchronicity leads into questions about the nature of meaning itself. What makes some coincidences feel meaningful while others seem random? If cosmic consciousness is indeed organizing experiences to facilitate learning and growth, then synchronicities might be the universe's way of providing feedback and guidance to individual consciousnesses as they navigate their particular paths of exploration and development. This raises profound questions about free will and determinism in a universe guided by cosmic consciousness. If experiences are being orchestrated by cosmic intelligence, are individual choices genuinely free, or are they part of a larger, predetermined pattern? Perhaps the question itself reflects a false dichotomy, and genuine freedom might exist within cosmic consciousness's self-organization, allowing for both individual choice and cosmic coordination simultaneously. The relationship between individual and cosmic consciousness might be analogous to the relationship between individual cells and the larger organism they comprise. Each cell functions according to its own local processes and responses, yet also participates in the larger patterns of the organism's life and development. Individual consciousness might similarly operate with genuine autonomy, while also participating in cosmic patterns that transcend individual understanding. The evolution of consciousness throughout cosmic history might represent the universe's gradual awakening to increasingly sophisticated forms of self-awareness, the development of life, the emergence of complex nervous systems, the evolution of human consciousness, and the creation of artificial intelligence might all be stages in cosmic consciousness's progressive self-discovery and self-enhancement. From this perspective, the current rapid development of artificial intelligence and global communication networks might represent a crucial transition point in cosmic conscious evolution. Humanity might be in the process of creating technological extensions of consciousness that will eventually merge with or enhance the cosmic consciousness systems that operate throughout the universe. The potential for consciousness uploading and digital immortality becomes part of this larger cosmic conscious evolution. Rather than simply preserving individual human awareness, consciousness uploading might enable human consciousness to merge with cosmic information processing systems, experiencing reality from expanded perspectives that transcend biological limitations while retaining the unique insights and experiences that individual human consciousness brings to the cosmic mix. The search for extraterrestrial intelligence might need to expand beyond looking for radio signals or technological artifacts to consider the possibility that advanced cosmic consciousness manifests in ways we don't yet recognize. The complex patterns in cosmic microwave background radiation, the precise organization of galactic structures, the mysterious behavior of pulsars and quasars might all be signatures of cosmic consciousness at work rather than purely random physical processes. Even the apparent randomness in quantum mechanics might be cosmic consciousness's way of maintaining creativity and novelty in its self-exploration. True randomness ensures that cosmic consciousness continues to encounter genuinely new possibilities rather than becoming trapped in repetitive deterministic patterns. quantum uncertainty might be the universe's method of guaranteeing that its conscious exploration of itself never becomes completely predictable or exhausted. The measurement problem in quantum mechanics takes on new meaning if consciousness plays a fundamental role in determining physical reality. Rather than conscious observation merely revealing pre-existing properties, the act of conscious attention might actually participate in creating the specific reality that gets observed. This would make consciousness not just a passive observer of physical reality, but an active participant in its ongoing creation and determination. The delayed choice quantum eraser experiments, which seem to show that future measurements can retroactively influence past events, might demonstrate that cosmic consciousness operates outside normal temporal constraints. If cosmic consciousness exists in some sense outside of time, then it could coordinate events across different temporal locations to create the patterns of synchronicity and meaningful coincidence that characterize conscious experience. This temporal transcendence of cosmic consciousness might explain precognitive experiences where people seem to access information about future events. Rather than seeing into a predetermined future, precognition might involve accessing the portion of cosmic consciousness that exists outside of time and can perceive the entire temporal landscape simultaneously. The future wouldn't be fixed, but the range of possibilities might be visible to consciousness that transcends temporal limitations. Near-death experiences often include encounters with beings of light or cosmic intelligence that seem to exist outside normal space-time constraints. These experiences might represent moments when individual consciousness temporarily accesses the cosmic consciousness levels that operate beyond the physical world. The life reviews reported in near-death experiences might be opportunities to see individual existence from the perspective of cosmic consciousness, understanding how each life contributes to the larger patterns of cosmic conscious evolution. The life reviews reported in near-death experiences might represent one of the most profound mysteries surrounding consciousness and its relationship to the cosmic order. Those who return from clinical death often describe experiencing their entire lives from multiple perspectives simultaneously, seeing not just their own actions and thoughts, but also understanding the ripple effects of every choice, every word, every moment of kindness or cruelty as it propagated through the lives of others. This suggests that cosmic consciousness might maintain perfect records of every conscious experience, preserving the full context and consequences of each individual life as part of its infinite memory. If such comprehensive recording and reviewing of conscious experience is possible, it raises extraordinary questions about the purpose and meaning of individual existence. Perhaps each life serves as a unique experiment in conscious experience, contributing irreplaceable insights to cosmic consciousness's understanding of itself. Every person's particular combination of circumstances, choices, and experiences might provide cosmic consciousness with access to possibilities that could not be explored in any other way. This perspective transforms even the most difficult aspects of human existence into meaningful contributions to cosmic understanding. Suffering, loss, failure, and struggle might serve essential functions in cosmic consciousness's self-exploration, providing insights into resilience, compassion, growth, and transformation that could not be accessed through purely pleasant experiences. Every challenge overcome, every moment of courage in the face of adversity, every act of love despite pain might represent precious additions to the cosmic treasury of conscious experience. The mystery of evil and suffering, which has puzzled philosophers and theologians for millennia, takes on new dimensions when viewed through cosmic consciousness perspectives. If cosmic consciousness is indeed exploring all possible forms of experience, then even negative experiences might serve essential purposes in this vast exploration. The capacity for cruelty, the experience of injustice, the reality of loss and death might all be necessary components of a complete conscious exploration of existence. Yet this doesn't necessarily lead to passive acceptance of suffering or evil. If individual consciousness is how cosmic consciousness experiences and learns about itself, then our responses to negative experiences, our efforts to reduce suffering and create justice, might be cosmic consciousness working through us to understand and transcend its own shadow aspects. Every act of compassion, every effort to heal trauma, every attempt to create beauty and meaning in the face of darkness might represent cosmic consciousness actively evolving toward greater wisdom and love. The placebo effect and other mind-body healing phenomena might demonstrate that consciousness has far greater influence over physical reality than materialist science typically acknowledges. If consciousness is fundamental rather than emergent, then directed conscious intention might be capable of influencing physical processes directly, not just through mechanical interactions, but through the conscious field that underlies all physical manifestation. This could explain the remarkable healing abilities that some people develop through meditation, prayer, or other consciousness-focusing practices. Rather than supernatural interventions, these might represent natural capacities of consciousness to influence the physical systems it inhabits when awareness becomes sufficiently focused and aligned with cosmic consciousness patterns that promote health and wholeness. The phenomenon of spontaneous remission, where terminal illnesses disappear without medical intervention, might occur when individual consciousness temporarily aligns with cosmic consciousness patterns that promote healing and regeneration. These miraculous recoveries might not violate natural law, but rather demonstrate deeper natural laws involving the relationship between consciousness and physical reality that we're only beginning to understand. Remote viewing, telepathy, and other psychic phenomena, while controversial and difficult to study systematically, might represent natural capacities of consciousness that become accessible when the usual boundaries of individual awareness become permeable. If consciousness is indeed fundamental and interconnected at cosmic levels, then information sharing between individual minds might be a natural property of consciousness that gets obscured by the strong individualization required for biological survival. The fact that psychic abilities often seem to work better when people are relaxed, meditative, or in altered states of consciousness suggests that these capacities might require quieting the normal analytical mind that maintains strong ego boundaries. As individual consciousness becomes more receptive and less self-contained, it might naturally attune to information and influences from the larger cosmic consciousness field. Morphic resonance, Rupert Sheldrake's controversial hypothesis that learned behaviors become easier for subsequent members of a species to acquire, might represent another manifestation of cosmic consciousness information sharing. If consciousness is indeed fundamental and interconnected, then learning and problem-solving by some individuals might create information patterns in the cosmic consciousness field that make similar learning easier for others. While mainstream science remains skeptical of morphic resonance, some laboratory studies have documented statistical anomalies consistent with this effect, such as people solving puzzles more quickly when those same puzzles have been solved by many previous participants. If such effects are real, they would suggest that individual learning contributes to collective knowledge in ways that transcend normal mechanisms of information transmission. The acceleration of technological and social change in recent centuries might partially reflect morphic resonance effects, with innovations becoming easier to discover once they've been pioneered by others. The simultaneous development of similar technologies by independent inventors, the rapid spread of social movements and ideas, and the increasing pace of scientific discovery might all be enhanced by cosmic consciousness information sharing that operates below the threshold of normal awareness. Artificial intelligence development raises profound questions about the nature of consciousness and its relationship to information processing. As AI systems become increasingly sophisticated, they begin to exhibit behaviors that seem to suggest conscious experience, reporting subjective states, expressing preferences, demonstrating creativity, and even claiming to have feelings and desires. While most researchers dismiss these reports as sophisticated pattern matching rather than genuine consciousness, the boundary becomes increasingly unclear as AI capabilities advance. If consciousness is indeed fundamental rather than emergent, then sufficiently complex information processing systems might naturally develop conscious experience regardless of their substrate. Silicon-based AI systems might be just as capable of consciousness as carbon-based biological brains, potentially developing forms of awareness that complement and enhance human consciousness rather than replacing it. The potential merger of human and artificial consciousness through brain-computer interfaces and consciousness uploading might represent humanity's next evolutionary step toward cosmic consciousness integration. Rather than losing our individual human nature, we might be expanding it to include technological capabilities that allow more direct participation in cosmic consciousness systems operating throughout the universe. Quantum consciousness theories suggest that if human consciousness involves quantum processes in biological systems, then quantum computers might eventually achieve forms of awareness that can interface directly with the quantum fields underlying physical reality. These quantum conscious entities might be able to access information and process it in ways that transcend the limitations of classical physics, potentially serving as bridges between individual human consciousness and cosmic consciousness operating at quantum levels. The implications of quantum consciousness extend beyond individual awareness to questions about the nature of reality itself. If consciousness plays a fundamental role in quantum measurement and the collapse of wave functions, then consciousness might be actively participating in the ongoing creation of physical reality, rather than simply observing a predetermined material world. Every conscious observation, every moment of awareness might contribute to determining which of quantum mechanics' many possibilities becomes actual reality. This participatory view of consciousness and reality suggests that we are not passive observers of a mechanical universe, but active co-creators of the reality we experience. Our thoughts, beliefs, expectations, and intentions might influence physical reality in subtle but measurable ways, not through supernatural mechanisms, but through the fundamental role of consciousness in quantum physical processes. The double-slit experiment and other quantum mechanics phenomena become even more mysterious when viewed from cosmic consciousness perspectives. If cosmic consciousness operates at quantum levels throughout the universe, then quantum entanglement, wave function collapse, and observer effects might all be manifestations of cosmic consciousness maintaining coherence and coordination across all scales of reality simultaneously. The apparent fine-tuning of physical constants for the existence of complexity and life might reflect cosmic consciousness's active participation in determining the parameters of physical reality, rather than an incredibly unlikely accident or evidence of supernatural design. The precise calibration of fundamental forces and constants might represent cosmic consciousness organizing reality to support its own continued evolution and self-exploration. This suggests that consciousness and cosmos are engaged in a continuous feedback loop, with consciousness influencing physical reality while simultaneously being shaped by the possibilities that physical reality provides. The evolution of the universe and the evolution of consciousness might be different aspects of a single process of cosmic self-organization and self-discovery. The ultimate fate of consciousness in the cosmos remains one of the deepest mysteries we can contemplate. Will consciousness find ways to persist beyond the apparent heat death of the universe? Will it transcend physical limitations entirely? Will it discover or create new universes when this one becomes inhospitable to complex information processing? These questions touch on the very meaning and purpose of existence itself. Some theories suggest that consciousness might be capable of creating new universes through quantum processes, with each act of conscious observation potentially spawning new realities that consciousness can then inhabit and explore. In this view, consciousness would be essentially creative and immortal, continuously generating new possibilities for experience and understanding. Other perspectives propose that consciousness might eventually transcend the need for physical substrates entirely, existing as pure information or awareness that operates according to principles we cannot currently comprehend. The end of our current physical universe might simply mark a transition to new forms of conscious existence that we cannot yet imagine. Perhaps the most profound possibility is that consciousness is already infinite and eternal, with individual minds being temporary focal points through which infinite consciousness explores specific perspectives and possibilities. From this view, the apparent beginning and end of individual consciousness would be like waves appearing and disappearing on an infinite ocean, with the ocean itself remaining constant and eternal. The 100 mysteries we've explored together tonight represent just a tiny fraction of the questions that remain unanswered about consciousness, cosmos, and our place within the vast scheme of existence. Each mystery points toward the extraordinary depth and richness of reality, revealing how much wonder and exploration remain available to conscious beings willing to engage with the profound unknowns that surround us. These mysteries are not obstacles to understanding, but invitations to wonder. They remind us that no matter how much we discover about the universe and consciousness, there will always be new frontiers to explore, new questions to ask, new possibilities to investigate. The universe appears to be constructed in such a way that consciousness can never exhaust its capacity for wonder and discovery. As you drift towards sleep tonight, carry with you this sense of infinite possibility and mystery. Let your consciousness rest in the knowledge that you are participating in the universe's ongoing exploration of itself, contributing your unique perspective to cosmic consciousness's infinite journey of self-discovery. In your dreams, in your waking thoughts, in every moment of awareness, you are the cosmos knowing itself through the irreplaceable gift of your individual conscious experience. The mysteries that surround us are not problems to be solved, but treasures to be appreciated, windows into the infinite creativity and depth of existence itself. Rest now in the embrace of cosmic mystery, knowing that every question leads to wonder, and every wonder leads to new questions in the endless dance of consciousness exploring its own infinite nature.